Good morning, everyone. I hope you're all good. Let me just share our little live stream with everyone. Yes, as the live stream suggests, we are off Linux and back on Windows. We are doing billboards, but we're going to do a bit of studying beforehand. Let me just get up the live chat. Yeah, so the reason I realized I need to do a bit of studying is because I haven't revised any of the maths that we did 2 streams ago. And yeah, so yeah, let's get on that. So before we do that though, let's explain as I boot up my apps. So we're gonna be Obsidian, mostly reading, just doing revision, I think, rather than straight studying. And then yes, billboards after that. We have some of the work for that done, but we haven't finished. So yes, we're going to be messing around with that. Now, for anyone who might be watching who didn't see the last live stream all the way through, what did we end up doing yesterday? Well, we significantly reduced the amount of warnings, and we got this all running again in Linux. It would still need wider testing to make sure this is releasable on Linux. I need to make sure that the shared libraries are connectable and able to be ran. You know, if I just give you the shared libraries, I need to be able to, you know, you need to be able to go, okay, yeah, here's the shared library that I need to access. So yeah, we're still not quite there yet with let's just check the audio levels, with making sure that Linux is completely legit and spot on. But for now, we are going to be good on most things when it comes to developing. So I obviously, after the stream, I pushed everything to Windows. I merged everything in. We are now back on the on the space branch. Nothing has changed in the actual application. I will run it though, just so you can see where we're up to still. If I were to turn off, you know, we have the start menu, right? We're going to leave this until we actually need to change it and upgrade it. So we still have the same old engine. Nothing crazy here. Except when that happens. I need to pause that. Yeah, that music's a bit loud, so I'm just going to pause that real quick. If I tell you to be quiet, there we go, thank you very much. Right, let's bring this back up. Okay, so apologies for that interruption. So yes, we still have the same old. We still have the duck flying around. We still have asteroids with specular instability, which kind of looks kind of fitting. We'll see how that grows with other models. Yeah, so that's what we have at the moment. We have some of the billboard stuff done. Like I said, I merged everything in. That's about it. There isn't really much apart from that. You can check out my GitHub history. The link of my GitHub should be in the description of the live stream if you are new to this. Yeah, just make sure it's actually there. Right. Okay. So yes, the top link is actually the Foundations in Game Engine Development book, but the one below that is the GitHub link if you're interested in seeing that. So yes, we do have that there. And yes, next. Okay, so the first thing I want to do is, because I was so stuck on getting things working in Linux, I didn't do any of the revision on the maths or split this up into little. So this is what we did 2 streams ago. We kind of went through this. We did a bunch of, you know, basic linear algebra. We didn't quite finish on the distance of a point between a line using a rejection when you subtract 2 vectors from each other. Basically this picture right here. Yes, I'm just going to do a bit of revision, because I need to, as soon as you've studied something, in my opinion, the next day is the best way to revise it after you've done it, and I didn't do that. So we're going to be doing that today before we do billboards, which, you know, yeah, the question is, where do I put this? In my, so this is Obsidian. If you're not familiar, this is a it's a note-taking app, and if I open this up, graphics theory, we should see. Let's make sure. Yes, I did post that. Okay. Yes, I do have a big index here of things. And I think I'm just going to stick it in maths, but maybe linear. I used to split up maths as well. I don't know. Because we've got probability, continuousness, and which is all to do with. Oh, this song is so good. Yeah, and the rest is just linear algebra / geometry, which is very different types of maths. But anyway, yeah. So let's what I'm gonna do is split things up so it's like this, like a little note to myself, because that's important. Oh, and final thing, I guess I did. This is, I guess, very minor, but I made all those notes a bit more. I filled out those Linux development notes that we, chat was helping with yesterday when it came to Vim. But yes, we're back on Visual Studios. We're back on like the regular development of things. So yes, let me. So what I'm going to do is just also read out the triangle mesh and all that kind of stuff, and make sure I understand how we are getting the normal vectors from things and the normal matrix and the adjunct matrix, which is just how you get the determinant inverse matrix without, sorry, how you calculate a way of calculating a determinant matrix without the determinant in there. And then, yeah, I think we're pretty solid. Right, okay, so let's grab this and make, so the closest, okay, so we want to say triangle mesh maths, I guess. I don't really know how to say this to make it stand out. Let me just think for a moment. So V is the number of vertices. Okay, so this is the Euler's formula. Yeah, okay, so yeah, this is all game dev maths, so it's not like strict, like I'm not being so coherent with my maths. Sorry, rigorous is the right word. Yeah, I just say triangle mesh. I don't really know. Maths, I guess. That'll do. So yes. Yes, we need to make sure that we have this tagged. And then basically how I do this, if you're interested, is I usually split these up into subheadings, so I can just do this. And then basically I'm never gonna read like a 1,000-page massive long thing all on maths, right? That's just like reading a book. But what I will read is like this, right? This is much easier to chew through, and then I can if I want, I can then branch out into other things based on my interests. So yeah, that's and this all maths came from the foundations of game engine development, which is the link in the description. The first one is that book if you're interested. It's a very good book, and it's one of these things where mathematically, game development hasn't changed at all. It's still the same maths. Hello, 590, of course. Hello. I hope you're having a good day, my guy. Thank you for joining us. Yes, so normal vectors. This is just let's see a normal, a basics. Is it basic maths or maths? Maths. Yeah, normal vector maths. I know it's kind of redundant to put maths and everything, but I want to be able to like independently know what I'm talking about rather than just say normal vector. It's kind of a bit vague. So yes, partial derivatives, because we're doing it over different coordinates. It's not that complicated, to be honest, but yeah. So we're just going to connect these ideas together. So the triangle mesh is kind of related, and it comes from the same book, which is Foundations of Game Development Maths, which is the I think there's only 2 out. Let me check. If I scroll down and open up my description, yeah, so Materials and Models was supposed to be the next one, but I don't think he's ever finished this series. Yeah. Yeah, the problem is with these books, he never finished. I don't know if he's going to go back and finish them, but Materials and models is supposed to be next. In fact, I had a different cover originally. It used to be a skeleton. Sorry, I'm just looking at the link, if you guys don't know. So the volume 3. So the first one is, this book is volume 1, which you can purchase. Which has a really nice introduction to maths. If you do understand it properly, you will be better off as a graphics programmer. Rather than just steamrolling through it. Which is kind of what I did. I mean, I kind of did study it, but let's bring up the chat again. Okay, there we go. Okay, normal maths. Right, let's go through this. So the revision, how I do the revision, I just reread when I've written and make sure it's, you know, the spelling mistakes are out there. So normal vector maths. So the normals, so normal vectors, I think. Yeah, we're a lazy Brit. Yeah, pretty much. I kind of was like, hey, yeah, I understand this. The problem is, having a superficial understanding of things is kind of, you kind of convince yourself you understand them deeply, but like I would look at this, for example, and be like, oh yeah, I understand what this is doing. Yeah, definitely. Yeah. And then if I was just like to try and sum this up to anyone who's watching this, I wouldn't understand what was going on at all. Like, I wouldn't be like, oh, we're doing a partial derivative to, I'd like fall over. Like, I would understand the, like, what it's trying to do, but I couldn't explain the steps. And the steps are like, we are trying to find the point on this function here of what the normal vector should be at that point, right? And then we do partial derivatives over each. I think it's right, actually. I think it was just xxx like 3 times. I think it should be xyz. Yeah, so even that's a little bit wrong. So this is like part of the point of re-going over it. I'll have to check that just in case, but yeah, I think that's wrong. Oops, that should be z. And looking at... Yeah, just because you own the book doesn't mean you understand it. The 5090 Ti, yes. Am I loaning this out again? I mean, all you have to do if you want a free graphics card, by the way, is definitely just donate me the money, and I'll definitely get it to you 100%. I won't definitely delete my YouTube channel immediately and disappear. Yeah. So let's read this properly. So the normal vectors are given a scale function. Oh yeah, p, fp, and a normal vector at position xyz is given by the gradient of, yeah, okay, so this is a gradient, right? It's important. Function. I don't know how to write this delta upside down. Because it's perpendicular to every tangent direction to a surface f at point P. For example, if we have an ellipsoid of this point, so this is found on the original, what is it called? And then we're trying to find the gradient version of it. So, you know, this thing lies on this, there we go, spelled it wrong, surface of the ellipsoid. The normal vectors at n-vec given at normal vector n at the given, at the point gives, there we go, that's what I was trying to say there. So yes, the gradient function equals this over point P, and then yes, then we do the partial derivatives. So that's the actual normal vector if we have that point on that surface. It's normal. Normally, we don't do this outside of modeling software, which approximates the ideal surface described by some maths formula. Maths formulas. Right. If we want to calculate the normal vector, we can use the triangle's vertices with a cross product projection. Vector cross project, is it vector cross project? What you project, yes. I can't remember if that's actually the... what I'm trying to think is that the identity for a cross product when it comes to a vector projection? Give me a minute. I think I've written down some of the vector projection stuff later on. Because we need to be able to... So that is the adjunct matrix. That's the... Yeah, so it is X, Y, Z. Okay, that's good. At least we know that's true. Vector projection. No, I don't think I wrote down any identity. Alright, cool. Yeah, okay. I'll leave it then. I'll leave it. It's probably true. I just wanted to make sure if it's actually true. I haven't written it down, so I can't really trust it. But that's fine. We just have to create the tangent vectors from the point. If the cross products, if you do the cross product differently, you can end up with a normal vector that faces inward. If you want to make sure that it's correct, it's the correct way around. Always do the first subtraction of points. Okay. Let me go back. The first subtraction of points should be chosen in an anti-clockwise direction. Okay. Yes. Okay, that's fine. That's actually more makes sense. Okay, so we've done that. We split that up. Next is, so that's what a normal, how you calculate normal vector, transforming normal vectors. So I think I've got two things here apparently. So tangent vectors aren't affected by matrix transforms because they are calculated based on vertices of a model, meaning that when P1 and P2 are transformed by matrix M, then the tangent vector T is just MT. However, normal vectors can't be transformed this way. If we scale a model non-uniformly, this scales normal vectors in a way that destroys perpendicularity. Okay, so the problem with transforming vectors, I'm going to say, the problem with transforming normal vectors. So what that's saying is, yeah, because it's a gradient function that we use to calculate things, it kind of breaks if you scale things non-uniformly. When I say non-uniformly, I mean like like a scale factor, for example, it's like twice in the x direction and stuff like that. So okay, mathematics. This is very normal vector. Normal vector maths. And so what I'm doing here, for those who don't know, I'm making links. So it's like a Wikipedia kind of article system where I'm able to like click backwards and forwards between different articles. And this an article would be like this, right? And the other thing I need to make sure I do as well, as I just realized, yeah, so I need to put these here so I can click on them afterwards. Because these are all, this is mostly related to graphics theory. This is pure just maths, obviously, but yeah, you need to know maths to be able to do graphics theory. Which, it's funny, it's one of these things that it doesn't matter if you're using a game engine, like you can't escape this. I was talking about this with some other game developers. They struggle with something, they often struggle with shaders. They always say like, oh, shaders are really difficult, and for a while I didn't understand what they were talking about. I was like, why is shaders in particularly difficult? And then it kind of clicked. I was like, ah, that's why it's difficult, because they can't escape the maths. You have to know the maths to do shaders, right? Because that's what all this mathematics is actually applied. And it doesn't matter if you're using it doesn't matter what the engine is. If you're going to improve your graphics ability, right? So if you're going to make the graphics better in your game, there's nothing you can do you have to use shaders to do that. And because you have to use shaders, you have to know graphics theory, and graphics theory is very maths heavy. So because a lot of these game developers I talk to aren't, I wouldn't call them game developers personally, but they call themselves game developers, so I'll just refer to them as that. I would call them game designers, because they don't really care about the actual craft of programming. I feel like if that's your state of mind, then you're probably more of a game designer. And that's not me being elitist. I think that's fine to be either, right? Game designers have to code. It doesn't, doesn't mean anything if you can be a fantastic game designer and make it like a killer game, right? But it does mean that when these guys come across something like what is it called? This, maths, where they don't really care, programming's just an obstacle for them to actually do the game design idea they have in their head, then all of a sudden they get kind of like, confuffled, and they're like, shaders suck, and it's like, yeah, it's the final skill check left, I think, in game development, where it's like, it doesn't matter how you go about game development, this still comes up, assuming that you want like better graphics. If you want to do a 2D game where it's like really simple, like fair enough, you don't have to do any of this. But this is still, you still get skill checked on this. Yeah, so I need to change this as well. So this is one thing I kind of regret doing, because it kind of made it kind of messy. And then I'll read this properly. Like, yeah, you can't escape. Oops. I think it's kind of funny. Game development was so hard when I switched to. Game development was so hard I switched to graphics programming. Yeah. There you go. Some people just love the difficulty. No, yeah, but you see what I'm saying, right? Yeah, it doesn't matter what you end up using. That's why I've said on the stream a couple of times that game development it starts out being very difficult making your own game engine versus using a game engine, but in the end the difficulty levels out, because you end up having to do the same things anyway. You end up having to battle the game engine to do what you want. You end up having to do this and that. It's like a very difficult kind of people just say, I want to make a game, so I use a game engine, but then like the difficulty like comes later in the process. It's not immediate. And like this stuff is stuff like people just, this is the last thing, like an artsy fartsy type, no shade, but yeah, this is the last thing they want to be doing, is this type of thing, right? Where they're studying like, oh, what's a normal vector do? How do you work out the gradients? What's the delta? How do you do the delta calculation in that? That kind of thing, right? Because it's so like not what they want to be doing, which is typically designing a cool game design idea and making something that they want to play, right? This is just getting in the way of what they want to do, right? So that's what I talk to them a lot, because I also run a game development, just like a general game development Discord server. It's just like, for people who are just doing it, whatever. It's like a really small one. And I'm actually hosting a game jam on there as well, which is kind of funny. Similar to the one I hosted. Yeah, I made a video about it. If you've watched all my videos, maybe you haven't, but I made a video about a game jam, and that was like the same thing. Hello, Emmanuel. Hello. Doing a bit of maths today. I hope you're here for it. And so, yeah, oh, missed one. Missed one. Just doing a bit of revision before we kick off the day with some billboards. Okay. Later, your custom engine gives you convenience that commercial ones won't. Exactly, right? When I talk about being very specific and very careful with what I implement, that's why. Later down the line, that's going to help. Assuming I've done things correct. And it has started to help, right? Like, I know this is going to sound like narcissistic, but graphically, like, already it's not really a game yet, right? But my tech demo, you could say, is starting to like surpass some of the people's other, like other people's that I've seen in my other community that I run for game developers. Graphically it started to get past them just because I can do things that they struggle to do or can't do with their engine because of some weird restriction that they, and this is also last thing I'll say about this is like, this is why I also say stick to something. I see so many game developers like swapping engines over and over and over again, and I'm like, if you just stuck to one, you would get used to its like its awkwardness, and you'd be able to okay. But like I said, they're so focused on the game design idea they have in their head, they just want to be able to express that in any way possible, that anything they do, like any game engine like annoyance that they have gets in the way, and it kind of trips them up, I think, because they don't stick at it. But anyway, so that's just like a thing I've seen, like a pattern, a reoccurring pattern that I've seen over and over again. That shaders are difficult for them, and they don't stick at an engine enough because they're just interested in their ideas being expressed rather than the craft of the actual programming, which is what I'm interested in. That's why I do my whole game engine right. Anyway, handling normal vectors when transformed. If you have a vector A, vector in, so vector VA, okay, I have to say where A is a, what is it called? Space. I'm guilty of constant swapping too. yeah, I don't recommend it. I definitely, if you can, I know it's tough. Like I don't want to be like that guy who's like, beating you over the head with stuff, But if you can stick to it, it's definitely, I think, in the long run, better. Maybe not in the short term when you're getting stuck on a annoying thing, right? But I think if you can stick to even something like Game Maker, right? If you can make a really solid Game Maker game, because you've just decided to stick with it, like that's, I think, better than like switching. From what I've seen anyway. Again, I don't do either of those things because I'm in my own engine. So anyway, so if we have a vector V, I'm just going to say V instead of that, where A is a space. If we transform A by M, then AX of VA adds up to total length. Okay, so I've also got to say, so we are going to make a sample problem below to explain the issues with normal vectors and transforming them into a biomatrix. Transforming them into a into a different space. Hello, Kalia, how you doing? But at the end of the day, the big loose goose, just so you're aware, like, I know sometimes people aren't like super hardcore with their game development. Sometimes, you just want to do it as a hobby, and that's also fine as well. That, because it's kind of difficult to say like what people should and shouldn't do based on things that I've observed, because it's very different depending on what people care about, right? Like, there are some game developers I've met that are only doing it for a hobby and they don't really care if they ever sell anything ever. So they don't like put like a lot of efforts in. Yeah, maths time indeed. So yeah, if you are just switching over and over again because you're just having fun, that's completely legit, right? But I think in the long term, if you want to get good, level up your skills, then it makes sense to kind of stick with one thing. Just installed Vulkan. Oh, here we go. Callie is ready for Vulkan. Let's go. 1.4 is supported. Yeah, it should be. Most graphics cards, like, you would have to go quite far back, honestly, to not have 1.4 supported. On GPU graphics cards, anyway. I think they branched on some really old graphics cards with 1.2. But you have to have a really old graphics. It's like last time I checked, it was vaguely remembering it was if you have an NVIDIA GTX 600 series, which is like nearly, I think it might be like 30 years old or something. Then you don't get it. Then you don't get Vulkan 1.4. It's like a really old graphics card. My GPU has 2 gigs of RAM. And yours is, yeah, I don't know AMD as well. I don't know the naming conventions as well. Anyway, this is used to make a mathematical point, nothing. Okay, so I'm just going to get rid of this, as I was a bit confused. We can express VB and VA in B's coordinate system by this transform. Now, is that? Yeah, okay, so X is equal to these, so that makes sense. We do the same for Y and Z. Yes, we did for X here. We can build up a transformation matrix of vec B that corresponds to the original vector vec B. I think it meant to say... one of these is incorrect, actually. Let me look at my book. I've got this backwards. One of these is wrong. This is why we look at our notes to make sure this is correct for the future, so I don't end up getting super confused. Let's go into my books, and I'm going to pull out the... Where is it? There it is. Alright, so I'm just going to dive into... this was chapter 3, so I think it's going to be like halfway, about here. Bit higher than that, which is fine. It is here, so by adding these coordinates... Okay, so yes, if I read that again... Transforming vec A, it corresponds to... Yes, okay, so... I think it's vec A into vec... Transforming vec A, that corresponds to the original... Yeah, okay, so... yeah. It corresponds to the original vector vec A. It's entirely... You can write this as a matrix multiplication, like this. Cool. We created a matrix vec A to vec B based on this definition. Yeah. It is hot today. Ugh, no. Yeah, it is kind of warm. It's not that warm in the UK, but I really hope it's not too hot for you, because you're in Germany, right? I really hope you have air conditioning. No, you're in Azerbaijan. So the heat wave must have traveled to you guys. Yeah, 28 to 28. I just remembered. Yeah, so it's blown. I think it must have blown off to the side. Yeah, Azerbaijan, that's the one. Oh, hang on, what's happened here? In its entirety. Day 4. Oh no, dude, that's horrendous. Unless you're kind of used to it, but I think... Yeah, that's entirety, okay. You can write this, that's what I want to correct, that's what's tripping me up, as matrix multiplication, based on the definition we defined above. If you consider the normal vector... Oh, by the way, for the people who have just tuned in, we got everything working on Linux yesterday. Linux is all good. All good in the hood. It's running just as nicely as Windows, based on the definition above. Okay, so if we consider a normal vector calculates things as a gradient, the key understanding is how such vectors transform. The key to understanding is how such normal vector transforms, realizing that the components of the gradients do not measure distance, but the receptacle of the distance. Not used to it. Definitely melting here. Or an F. Oh man, that's... Yeah. I've only ever experienced 36 degrees, and I stood outside briefly, and my goodness, it felt like I was in an oven. It was horrible. So yes, I empathize with you, despite not experiencing it right now. This is because you consider the partial derivatives that compose a normal vector, which considers a point on a surface, which is delta f. All those. The distance x, y, z are in all the denominators of the vector. Since this is so different, we write the normal vectors as a row matrix rather than a column for a regular vector. We should just the reciprocal of things. I think if I look at my book again, these are okay. So it's not using commas, but I think that's fine. Right. Okay. So this comes down to this. If we have a matrix of and a vector, if we have a matrix that vectors to coordinate system 8, okay, that transforms vectors, yes, to coordinate system A to B, then NB is given by the inverse and transformed tangent B is given by MT, and you have this product, right? Okay, so we have n dot B equals the inverse multiplied together. So this is the definition, and this means that they are still T and N are perpendicular. Okay, let me rewrite that. This means that, and these are vectors, right? So vec and vec N are still perpendicular in the coordinate system B after transformed by M. This is the problem you have to solve to move normal vectors. Sorry, transform correctly. All right. Hello, Tab. How you doing, dude? Yes, just a bit of revision today. So I think you were here for most of yesterday. So yes, we got everything working on Linux if you weren't here. So yes, we're going to be continuing on our development journey. But yes, first things first, a little bit of a revision on our maths that we studied 2 streams ago. Right, fantastic. The adjunct matrix. Yeah, the adjunct normal matrix, which is fine. Cool, fantastic. Because this is how you solve that problem of transforming by a... So the adjuncate normal matrix. Yes, don't use the inverse transpose matrix, use this one, because it's sometimes incorrect. It's incorrect sometimes over this one because the determinant, some matrices, when you try to do the inverse, you can't invert all matrices. And it's possible that you get a bad normal matrix based on that. I don't know what actually happens if you try to invert an invertible matrix on the GPU. You're probably just going to get kind of junk data. Well, junk data in the sense of mathematical accuracy. Maybe not like junk data in the sense you get garbage, but yeah, it's definitely worth looking into, which is quite simple actually, the adjunct matrix. It's actually faster than inverting a matrix anyway, so yeah, if you do this, which it takes in the model position, which is just my general matrix, and then you do that. You may already know this, but I just thought I'd say that this is how you transform your normal matrix normals, which is always correct and actually a little bit faster. So yeah, don't overlook that when you're actually transforming your normals. Because I was using what's always incorrect is just using the regular model position matrix, which was what I was originally doing, because as we found out earlier in the last note that we just talked about, because it's not measuring distance, it's measuring the gradient of that distance, so it's the inverse of the distance. You end up with basically bad normal vectors that point in the wrong direction. So yeah, get the educate matrix is peak. It's actually only half of a inverse anyway, if you do, because you can do an inverse like this if you. Anyway, I'm kind of rambling here. Let's just read this and you'll get the idea anyway. But yeah, it's good. This is why it's good to know maths, man. So anyone who's like studying maths, this is where your advantage kicks in. You may not be necessarily the best programmer, but you're going to be way better at this kind of stuff. So let's connect all my notes together. Let's put this at the top, actually. Change my mind here. And let's put you here as well, because actually put you at the bottom, because that is useful. Boom. What are you working on now? After the maths, we are going to do billboards. If you don't know what that is, it's just some 2D sprite that always faces the camera. So yes, we're going to have to do that, because that's the next effect that we need to put in the game. Because right now nothing's really happening. And what I'm going to do is just make it into a particle, right? After that's particles. I don't know the meta for particles yet, but at the very least I need to know how to do billboards, so we can actually get particles working. The thing I have to do after that, I think what I'm going to do to study that is, I've got a book called, just bear with me one moment. I've got all my books down right next to me. So we'll see how this goes, but sorry, it's stretched. I have a book called GPU Zen 03. I recently acquired this book as well. Yeah, I love books as well. And that has a whole guest lecture. What this book is a bunch of guest lectures on how they did like different things, and they have a whole section. Someone has written a technique on how to efficiently do particles. So I'm going to figure out like what they did. It seems relatively modern. This is 2024, so it'll be like a relatively good. And they did it on mobile hardware, so they were really concerned about making sure that. Where is it? It's which chapter actually? Let's just go to the chapters. So we might try and implement some of the ideas that were in this book. Maybe it might be overkill, but yes, chapter 6. So chapter 6, where are you? So that's chapter 7. Yeah, chapter 7 is like how ray tracing was used in what is it called? Cyberpunk. Yeah, so there's a relatively small chapter called Multi-Mega Particle System by Nicola and Wolfgang. So yeah, we're gonna be trying to dig through this, I think, and seeing what they did and like how we can implement our version. They were able to like make like really advanced particles. Ram a lot of particles into the system. It might be completely overkill, but at least we'll get some idea about like what is the what's the meta nowadays, right? Because that's what I don't know at the moment. I don't know what the meta is. And they were able to get like some high level performance with simulating fog with particles. So they had like a lot of particles on the screen. They had like regular particles spewing from a direction. Yeah, so we'll give that a go. And hopefully, and this was all on a the European Samsung Galaxy S22. So, so yes, an older, not a GPU, not a desktop GPU, but I think that's going to benefit us because they're going to be really performant no matter what we end up doing, even if we only do half or quarter of this. So yes, it's going to be get billboards working and then try and start rendering particles. So yeah, even if we don't know all the particle effects, like how to do the things, we're just going to end up looking stuff up. I'll try and get this book online, but it's kind of going to be a bit sketch. Trying to download a book. I own the book, so I don't really know what the legality is of like putting the PDF on stream, but I'll try and do that so it's not as boring to look at me just like reading a book like right now, right? So anyway, yeah, that's what we're going to be doing. We're going to be tackling this. And I think we can pretty much rely on this book being relatively good because it's got like, cyberpunk in it, like ray tracing, like really advanced techniques. It's got all the stuff that I studied, funnily enough, on sampling theory, which is fun. So yeah, that's for ray tracing though. I only read PDFs books. Yeah, I like to buy them because I want to support the authors. I love billboards. The only when you don't notice they are billboards. Yeah, pretty much. I want to because I want people to make good books. So I think I'm going to buy them to support them so we get more good books, right? If no one buys, if everyone, I don't know if you're buying the books on PDF mode. I don't know what people are doing with books. I'm not going to try and be a stand on a moral high ground about anyone in particular, but that's the motivation of me getting a book. I always try to buy a good book that I like, and yes, yeah, I prefer physical books, but obviously that's not good for streaming. I'm not going to be like, hey guys, I'm reading a book, unless I like have a book cam where we look at the book, and I might do that actually. It might be a setup and a half to try and pull off though. I also have a Kindle. That makes a lot more sense. Yeah, so I'll figure that out. I don't think we're going to get around to doing anything particle related unless I stream for a really long time. So yes, yes. So we will dive into this, and I'll make notes on it, and then we will. So I'm going to study it first, and then we'll implement what we've learned. So that's the plan anyway, because I want particles, and I think in space there's a lot of particles. So yeah, chapter 6 will be consumed with zealous and anger. So let's try and get to that point by billboards, because we can't really do any particles until we get that far. So I'll just put a bookmark in that book. Put that there. Yes. It also has chapters on GPU-driven rendering, which I'm really interested in because I eventually want to do that with my engine. I have done that in the past, and it's like really good if you can pull it off. Most graphics programming books are not available here, so I have no choice but to use PT. Yeah, no problem. I'm not gonna moral. Some of these are really expensive as well. That's the thing. Like, if you're in, I don't know, Venezuela, for example, right? The currency, the worst currency I know of on the planet is Venezuelan bucks. Like, there's no way that you're gonna get, buy a book that's £70 or something, right? That's like. That might be a month's wage, just straight up that you need to live off. I estimate there are at least a dozen particles in space. Yes, at least a dozen. Yes, at least a little bit more. Yeah, so let's dive in. Let's start the music again and dive into the mathematics. Again, this is all going to be shader stuff as well, I think. I don't exactly know, like I said, I don't know the meta when it comes to particles. One of the reasons I got that book is to find out what the meta is with particles nowadays. So I don't know if it's going to be pure compute, if we can do something with collision detection with them. It's going to be a bit of a research and development task, which is going to take a little time. But I think it's the next stage of the engine, is to getting like a nice particle system in it. So it's going to be a bigger task than just setting up billboards and then adding a particle system in, right? It's going to be a bit of a complicated one. which is fine by me. But you know, this is why we're here. Anyway, so let's read this to finish off what we've been doing. I recently bought the C programming book. It was shipping for almost a month. Oh, that's brutal. Yeah, it's tough, isn't it, when you have to wait for something you really want. Compute seems like the only way to do it, but I haven't really looked into it. Yeah, Ratchet was saying that's not the meta anymore. I don't know what it is. So, yeah, like I said, we've got a book here. It looks compute shader related, so I believe it probably is going to be. You know, I feel like it's the typical data, because it's, sorry to ramble a bit longer, but as far as with my limited understanding right now, anyway, because the compute. Because setting up a compute pipeline and getting this to run on the compute shader is gonna, because doing that, what I just described, is gonna be, sorry, a GPU is, what is it? It's is it multiple instruction single data? I can't. It's not SIMD. It's the other one. And I feel like particles really lend themselves to acting like pixels and triangles. When it comes to transformation, so I have a feeling that we have to use the GPU, but I don't know how yet. So we'll dig into that live, and maybe we'll all be able to make our own fantastic particle simulators and stuff like that. As we learn together. So yes. So I'm sure there should be something to do with the GPU at least. That's it. Yes. SIMD. Yes. Single instruction, multiple threads. Yeah, that's exactly how the GPU works. Thank you. I forgot the acronym and forgot what it meant. I knew it existed, but I just forgot the acronym. Yes, thank you, TT. So since I'm just going to read this. So the adjugate normal matrix. Since we are aware that normal vectors store the gradient and not the distance to scale, we need to treat normal vector like one column row matrix as described in handling normal vectors when transformed. To do this, we can just invert the matrix. If we do tvec and svec are tangent vectors, we can take these and do a cross product and get the normal vector. Assuming we take into we take into account this m, v, vx, bx, and cx, where a, b, and c are column vectors from matrix M, we can write n, b. Yeah, okay. Yeah, I'm gonna go back because I just realized something's just clicked in my head about this. Note this is totally correct, but not all matrices can be inverted. That's the confusing part that I kind of got mixed up. Inverted when I was reading this when I was making these notes for the first time. So this actually is correct when you use the inverse, but it's not all matrices can be inverted. I think I said that earlier, but that's generally the problem with using an inverted matrix. If I remember correctly, isn't it symmetric matrices that can't be inverted? I can't actually remember. Because they don't have any. I can't remember. I would need to reread that, but I think it's just a. Anyway, assuming we take into account this. Where did you learn Vulkan? Was it mostly from books or some stuff? I'll answer that in a minute. A great question, by the way. I just need to make sure that I plow through this. So, and it's a bit of a bigger question. That's all. I'll say, but I'll definitely reserve that for a minute. So SX, yep, BX. Okay, so that's just multiplied by the column matrices. If the determinant is 0, then the matrix cannot be inverted. Yes, that's right. But I think the determinant is that happens when you have a symmetric matrix, I think. Because everything kind of cancels out, as far as I remember. I'll have to look that up on Google. Anyway, MJ is just column matrices. We can simplify things down by distributing the cross product. We get, yep, this, and this. That's the for each component, which is one multiplication matrix. I had to write it like this because I couldn't do a matrix. Anyway, the cross product XA creates the determinant inverse. Determinant of the matrix inverse. We follow the equation. Works. Okay, so we have this. Fantastic. Which is determinant multiplied by matrix inverse. We can conclude that the normal vector calculates the cross product is correctly transformed according to this. Using the adjacate matrix, we get this. Fantastic. Alright, so after this, okay, this is not only normal vectors transformed, but how any vectors result from a cross product transform between regular vectors. Since we are dealing with normal length vectors, the size of the determinant is inconsequential and often ignored, making the thing here basically the same. That's why we can get away with not doing the inverse, because our vectors are normalized. Also, not all matrices can be inverted when the determinant of the matrix is 0, because you get a division by 0. So it's faster and more correct to use the adjacate matrix. Use the adjacate. This guy. I'm just going to copy the word because there we go. Simpler. This would look like this. We've seen this earlier, with one exception. When you reflect vertices, the winding gets reversed because you do a cross product between x and t and x because the cross product between t and v, let's just make these into vectors. \vec and s, we would be reversed by we would use the reversal would be, whoops, no H there, would be corrected for by the determinant. So be careful when reflecting vertices, as it reverses the winding. Okay. Yes. So, hey, are you doing maths today, bro? My head just started rotating. Yes, we're going to be doing maths, and then later we're going to be doing billboards. Thank you for joining us, by the way. I love melons. Hey, it's Beast from the Discord. I don't know if you remember me. Just had an interview, and they asked a basic question that I couldn't answer. Very disappointing in myself. I feel sad, man, but it's nice to see you live. I'm sorry. I'm sorry to hear that. Yeah, sometimes it is kind of disheartening. All you can do is just take on that and just realize that you're missing that area of knowledge, whatever that may be, whether it's language-based or maths-based or graphics-based or whatever it may be, and just kind of say like, well, next time that happens, that's never going to happen again. Yeah, it's a moment to reflect on and get better. So, Tab has asked, where did you learn Vulkan, and was it mostly from books or other stuff? And I will answer that, and I'll just pause. So the way I learned Vulkan, oh, I don't even have the timer open. I'll do that while it's probably not what I'd recommend to anyone anymore. I actually don't recommend what I'm doing. So I have learned Vulkan in a few different ways. I originally learned it from the Vulkan tutorial. So if I go to that, this was before I knew what I was doing. So this is not, I do not recommend this. Capital letters, do not use this tutorial. But I went through this, I think I've went through this 3 times. I did a little bit, not much, but I did a little bit of Vulkan Dev, the Vulkan Dev guide, which I do recommend if you actually want to follow something that's a bit more complicated and a bit harder to do. You'll be able to render this if you follow everything, which is these lights aren't real, by the way. These are part of the model themselves. They're kind of fake lights, but this is definitely a lot better. I did the legacy version. I was doing the Vulkan guide 1.1 when this was out. I then also read, I'm just, again, not to dox myself, I'm going to have to go in private window. Mastering Graphics Programming. Oops. I think I've talked about this book before in videos. Mastering Graphics Programming with Vulkan. I've gone through about half of this book. This, again, uses render passes. It's not as up-to-date as I would like. But you'll see the DNA of this book's engine in mine. Like, there's some DNA left over. Because it's still quite good in many different ways. But it's, I thought I'd dox myself there, thank goodness. I live in the UK, surprise, surprise. I have this book at the moment. That's what I would, if you're going to buy a book, I'd recommend this one. If you're brand new, if you want to get a book at least. Because this actually does go from setting up your environment, getting the window working, all that kind of stuff. But what I would recommend to people who are starting out is I would personally go to How to Vulkan. I think I've mentioned this before. It's pretty brief. It's very light on details. It will just speed you through things. You won't understand everything in this tutorial, in my opinion. But from my experience anyway, I think that's what people have said. They kind of struggle with this tutorial. But it's because it's faster and it will get you to getting things on the screen quickly. I assume that it's going to be easier to keep your motivation up because you're going to be going a bit quicker rather than like reading a book or something. So yeah, and I also did like half of, I can just do this as well. This is the other thing I did. I went through Arsini Karpulkin. This guy. This guy has a great series on Vulkan where he builds something called the Niagara render live on stream, and he has them all live here. He has you'll learn how to do something called meshlets, and again he starts out kind of older, but what's good about his series isn't necessarily the meshlets. That's really good. How to do mesh shading, but it's how to like organize a generally good simple renderer, right? This is actually this is like a really nice way of doing things without making things super complicated. It's actually really well written. I think he's the principal programmer at Roblox. So he's actually like really competent. He's been programming graphics since the Xbox 360. So I've gone through like that, and that. Apart from that, I've kind of learnt stuff that people have either sent for me on Discord. They have, I've talked to people on the programming Discord, on the Vulkan and graphics programming Discord. So there's like lots of different things that I've done to learn. I've made about 4 renderers in Vulkan before this one. I think I'm including this one. Yeah, so I've made 4. Yeah, I've made actually 4. This is my 5th Vulkan renderer game engine, right? So I've thrown away a lot. A lot of them were just like the tutorial, and then I just stopped using them. So I don't recommend this. So I've spent like a lot amount of time doing a lot of different things to get somewhere. But I do recommend this just because it's faster. You'll see if you actually want to do this, if you're actually interested in this kind of stuff. That's why I recommend this. Vulkan Guide's harder, but you'll be able to do more by the end of it. Or you can just buy a book, which I would personally recommend this one because it's newer. and it's got like, but it's like it's like over 1,000 pages, so it might be intimidating. And it's not as, it's a cookbook, so it doesn't quite take you from start to finish as nicely as like another book will. A lot of them are just like, we're going to implement this feature, and then we're going to implement this feature, and then we're going to implement this feature, without any like through, for a render anyway, without any like clear thread to like building a bigger game engine, right? It's just like, here's like different graphics techniques that you can try. So yeah, that's what I've done. I've also obviously read the graphics theory books, like I've read a bit of this, but you don't have to do that. Oh, and that's the GPU Zen. I have the GPU Zen 3, not that. So anyway, yeah, that's what I've done. So yeah, you can probably not take as long as I have if you just stuck to a resource and that wasn't this one, for goodness sake. Oh, I've gone through this 3 times. So yeah, that's what I would do personally. I think it's in my roadmap, all this. That book, yeah, I don't think I put that book in the mesh roadmap. Maybe I should actually. So yeah, that's what I would do. But yeah, that's what I've done. But that's what the question was, what I've done, right? Not necessarily. So I could not finish the Vulkan tutorial. It was too hard to follow the tutorial. You used meshes when using the book, if I'm not mistaken. Yes. The author says, we will teach you the basics and jump into advanced stuff in no time. Oh, and that other one? Oh, okay. I think I'm going to try... how to Vulkan today. Good stuff, yeah. People have struggled with that. It's not the easiest tutorial in the world, but I think it's faster to try and see if you want to do this. Because what I don't want to do is send you on a massive odyssey that takes like weeks or like a year, and then you're like, I hate this. What am I doing this for? When I could have just sent you down like a quick, dirty-ish tutorial where you can try it out, right? Yeah, so feel free, if you are going to try out Vulkan, make sure you reach out to community members. It doesn't have to be our community. But yeah, make sure that you've got like someone to help you if you get stuck. I did do a little OpenGL, so I think it would be easier. Okay, yeah, just make sure you can reach out, and people in my community I think will be willing to help if you do ask. But if you go into the programming Discord or the Vulkan Discord, I think either one's fine. And just ask questions when you're like, why is this happening? I don't understand why I'm getting this validation error, type stuff, right? Like, why is this not error? Why can't I see any textures? What's happened to my image? I hope so. Yeah, there is a bit of a barrier when it comes to... I can give you a list, actually. I would recommend... I'm not going to make this video, so I think I've fully decided that I'm not actually going to make this video. But I have a list of things that I personally would say... Oh my goodness, let's get to the end. Again, people could disagree in the live chat. I think I started to write the script. Yeah, so I would say that you probably need to at least understand all the basic types, int, float, and doubles, all the control stuff like switches and if statements, all the different types of loops, including do while. That often gets missed out, but while, for, all that kind of stuff. Some data structures that you have to use in SDL, so standard vector, standard stack, standard map probably being the most important ones. How dynamic works, what is the stack, how to allocate dynamic memory. Pointers, references, and double pointers are kind of good to know. That's just kind of nice. That will just help you. These are important. You need to know these. All the casting types, what they do. Different array, arrays are a big deal. So what is the difference between a dynamic and static array? Maps, queues, and stacks are I think more important later on, but I still think that's good to know. Functions, how functions, classes, and structs work. Arguments in functions, pass by value, reference, pointer. Pros and cons of these. Preprocessor things. Learn all the 3 different versions of static. That'll just help you out for global state. Learn how inline works. In my personal opinion, this isn't as important, but if you want some bonus points, learn the singleton pattern. It's probably the only design pattern I'll ever tell you to learn, because I think the rest are very situational. Inheritance, polymorphism, composition for OPP stuff is in has relationship basics. That is unfortunately inevitable, because it's anything that you learn is object oriented. Learn how to debug with breakpoints at the very least. Please know how to do this. This is absolutely fundamental, because when your program doesn't work and you don't know why, this is going to be the first step that you need to know how to do. This is not C++. This is just general debugging in general. Learn common runtime issues like dereferencing a null pointer, read access, and write access violations. If you know what these errors mean, then you'll be able to debug things faster. Learn a bit of basic consonants. This isn't as important for this tutorial exactly, but it's good to know. Again, this is just kind of just general C++ stuff. You don't really need to know this that much. Asserts are kind of useful. Yeah, it's a good idea to know when you're talking to other people, like what compiler you're on and what the different versions are. Basic templates. Yes, I would say that's kind of good to know if you don't know these. Nothing crazy though. Just, can you write me a function with a templates? Can you write me a class with templates? That's what I'd say. Lambdas after that are good to know as well. I think they turn up in the tutorial, so if you don't really understand lambdas, that's kind of gonna go against you. Libraries, well, you're going to be linking against libraries. Vulkan is a library to start things up with, so it's good to know what the difference between static and dynamic libraries are and how to link to them, I think. The size of operator, please know what that does. This is less important, but still good to know. Operator overloading. Learn how the constructors and destructors work of classes. That's going to help you understand like why things aren't initialized, like what's going on. Why is the error constantly saying that S type is not set? What does that mean? Why does that keep happening? Well, you know, it's something to do with this, right? Learn how to scope. Make sure you know all the different scopes. So like class scope, global scope. I think it's, what is it called when you have is it local scope when you just have a single brackets, and some file stuff because you're going to be loading files, right? Loading models from disk. How you actually load stuff from disk. Like that's what I would say. Like generally, like a good foundation of C++ will help you in general, right? So that's what I would recommend. These, maybe not exception handling. I'd probably remove that if it's just for graphics. But it's kind of good to know these two for general C++. Yeah, so that's what I would say like are a good starting point. I have left memory, pointers, and templates. Is it a complete list? No. This is like the minimum. If I was to send you off on learning graphics, I would assume, or if I was to hire you as like a junior programmer to do graphics programming, I would assume you know this. This would be like, okay, this is like the minimum that you need to pass. I would, if I was interviewing you for a job, for example, I would be asking you these questions. I wouldn't ask you anything else. I would ask you only these questions. Like, what does the capture clause do in lambdas? How do I, if I have a read access violation, what does that mean? If I'm using inheritance and I have a virtual destruct, what do I need to do with the destructor? You know, how do I make sure that we don't get object slicing? That would be under is-has relationships kind of stuff, right? I would ask you about memory. I would ask you about stacks. What's the difference between a stack and array? Maybe not when you'd use them, but kind of just like a general idea. This is what I'd be asking you. Like maybe not exception handling stuff. These are less important. But yeah, generally I would assume you would know these as a junior. I think I'm good for most of this stuff except OPP, cast, and templates. Got you. Okay, so yeah, I think you should just make sure you know them. You don't have to know them in depth, but they will come up. I wanted to be different and use WX widgets instead of IMGUI for my engine interface. Oh boy, I regretted that decision. Yeah, that's kind of a bold decision, I have to admit. Omega Killer, that's it's pretty brutal. Yeah, so maybe the reason I don't want to make this video, by the way, is in the end I decided that yes, it would be useful, I guess, for beginners, but I think just asking me questions on stream is going to be more beneficial. and I'm going to get a lot of comments saying, well, you forgot about this, how about this, you know, like a bunch of... I didn't want to deal with the comments and stuff like that, just because I generally don't feel qualified to make the guide to anything, right? It's just mostly a confidence issue, honestly, why I don't want to make this video. But that's how I would do. Yeah, at least if you know these and everything else, then you should be good. Because that's why people get stuck. They start learning graphics too early, and they don't. It just like this is just for C++. You know, you could whatever the equivalent is in Zig, Rust, or whatever. You know, same idea, same basics. You know, borrow checker would be in here probably for Rust. I don't know anything about Odin and Zig, so they would have to have other things replaced there. Yeah, so the reason I say inheritance, by the way, as well, like this, is just you can't reason about if object-oriented is good or bad if you don't know what it is. So that's my, like, even though I'm not even using, I try to use this as little as possible. The object-oriented stuff is good to know. Because now I can like make a reasoned decision about like, oh, I don't want to do this, I can do this. Anyway, there we go. Hopefully that was good. Even professionals cannot. Game dev journey is complex. It is hard to make a roadmap. Yeah, without a doubt. Yeah, I even had a programmer. I was even talking to a programmer I respect highly about this, and he said, yeah, if you can avoid learning C++, do it, because it's apparently really difficult. You know, he's a better programmer than I am when it comes to like general programming. He's not a graphics programmer, so he doesn't know graphics. And he was like, you know, most people can't even learn C++ well enough to even use it. So due to the fact you don't have any memory safety and things like that I would suggest. That's why I suggested like learn about like the error types that you can get. Read access violations, dereferencing null pointers. Again, that's just going to be a read access violation, but this is a particular type of read access violation. I think it's really useful to know. Like when you see this, when you see OXC00000F, you know what you've done. Like I immediately know what I've done when I see that error. Because it's not obvious what's happened there. And if you just know like generally what these do, then like, oh my goodness, like things just get less frustrating. Anyway, let's get back into it. Yeah, it's really tricky to make a roadmap because it's like, you know, have I even done the right thing? I don't even know, you know. Have I done enough maths? Is this too much maths? Yeah, it's a tricky one. So let's is this all connected up? I don't think it's in graphics theory. Let's throw this in. In my opinion, people should start with C and then use C++. Trying to start with C++ is not a good idea. At least that's what I think. Yeah, I can see that. I don't think it's a... I think when it comes to this kind of stuff, it's like no one has a right opinion, if that makes sense. So I think, yeah, you could start with C and then go to C++ because it's so much simpler. In the sense that it's like less... It's not easier, in my opinion. I think it's simpler. I think it just gets just as difficult. It's just like there's less to learn. It's just like... It's got a... If I just say it's like easier to understand the basics, hard to master. C++ is like... I would say it's like a medium difficulty in my opinion, but it's medium difficulty and then it's also hard to master, right? So it's like it has a less steep learning curve, but you will still have to learn like how to deal with, you know, null pointer nonsense and like accessing memory and all that kind of stuff properly and all that kind of thing. So anyway, let's get the next note. And then there's maths. Like I don't know enough maths to say what you need to know. This is the other thing I just kind of like, I don't know how to do this. Oops. Parametric lines. Yeah, I feel like if you knew everything I just listed, I would feel confident leaving you alone for a bit. You know what I mean? Like, as a junior. Obviously, you would need a lot of support. But I could give you a task if you knew how to do those things. Like, maybe if in my engine, for example, I could be like, alright, he knows how to do all these things. Try and add something to my engine. Like, try and do this, you know. If you knew all that stuff, I could be like, okay, he's going to be able to do that. You know, if I was able to give you a task, I could give you a task if you knew that. Okay, so parametric lines I don't think connects to normal matrices at all. That's why I say they're the minimum. It's not complete list. It's not like once you know this, you know everything. Vector projection, yes. So vector. Oh, okay. Control B. And like I said, no one really has a right opinion. So I'm going to connect back to parametric lines. Despite it not being related, they're kind of based on each other. Foundations of this. Oh, did I? Oops. Hang on. Parametric lines. Yeah, so you need to connect to. Oh, I didn't read it, did I? That's part this is doing. Yeah, so hopefully that wasn't too boring. Listen to me yap about programming. I'm just going to read this out. Given 2 points, P1 and P2, you can get this function for a line. For a line. For array, this would be defined over 0 to infinity, not including. And for a line, it would be negative infinity to positive infinity. We can easily rewrite this as this, where v. Okay, let's put this into a vec form. Backslash. Take this. It's just P2 minus P1. It's often the case that vec is normalized, so T corresponds to the V's length. Cool. How's the PBR renderer going along? Yeah, it's we haven't worked on it in a minute. I have to admit, we've been working on other things, but I feel like we've got a nice BRDF, a standard BRDF, which I can just show. It's basically what you saw. You've seen this before, Omega. So if I start this up, yeah. So it's like nice anyway, in my opinion. We have a just basic directional light, and we have a spotlight. Unfortunately, now we're deleting rocks. If you haven't seen that when we crash into them, but yeah, you can at least see it gets brighter as we get close. That is just to test us removing stuff from the scene. Yeah, so I saw people get overwhelmed in making games, even using a pre-made engine like Unreal because of C++. Because of C++. Yeah, okay. I started C++ right away. It takes some time to understand. It does indeed. I will come back stronger in C++. Hell yeah, I love that. I love that attitude, dude. It's like a really good, it's a really healthy attitude. I didn't start wanting to make games when I was starting out. I kind of just loved programming. So I had that advantage that early on I didn't really care what I was making, as long as it was fun. Okay, so sometimes we need to be able to work out two vectors that make up one vector by decomposing them into separate components. You can just get the length of x, y, and z axes to get the individual components of a vector. It's important to note that the basics of projection are easier. Sorry, it is important to note the basics to vector projection, I'm going to say. Vector projection gets easier. What am I trying to say here? It's important to note that basics of vector projection gets easier for general. If you have a basis vector, easier to understand. With when you work with basis vectors. That's what I think I was trying to say. If you have basis vectors for a space I, j, k, we take the dot product of I, j, I. Oh, yeah, that makes sense. Okay. And the same for j and k. In this case, things are normalized. However, to project properly, we we just use the general equation as. I'm just going to change the music. I think we're getting repeating music. Either way, we're on Ratchet and Clank a lot, so let's go with Wilderness. The Battlefield to do. I don't know where the Wilderness is. Okay, I forgot how quiet this is. Alright, I'm going to turn this up for now and then turn it down on the next song. Anyway, here we project a vector from A to B. We are dividing by 2B because B might not be a normal vector if the dot product is negative, meaning that the angle theta is between A and B is greater than 90 degrees. We get a negative projection. Meaning the projection faces the other way. Cool. This is so quiet. Why is this so quiet? So annoying. Anyway, that's vector projection. And we need vector rejection, which is just a very simple version of it. Sorry, when I say simple version, I think it's like a vector rejection. Oh. Okay, what is vector projection? No, I would say vector projection. Yeah, go there. Thank you. Oh no. Vector rejection. Stop trying to be helpful. I'm going to make a new note, just... Yep. Vector... Okay, vector rejection. Alright, cool. Get that in there. Yeah, I might end a little early today because I might have something going on. Hopefully that's okay for you guys. So yeah, vector rejection is just subtracting the original vector with a vector rejection. And if you, I think if you not add them together. How do you get the original matrix? Don't you get if you add them together? Yeah. Yeah. If you, wait, where's the picture gone? Get me the picture, bro. I need the picture. I need a picture, man. Alright, fine. Copy this twice. if you add the rejection and projection together. Hey man, how you doing, dude? Interesting you keep PNG files laying around as siblings as marked. Yeah, just throw them in. I don't really know what the correct thing would be to do here, but they're just all sitting here. I might put them in a folder, but I don't know if that's going to break the linkage. It just helps you get, I think you get the original. If I project and this at, right, you get the original vector if the projection wasn't negative. Yeah. Negative relative to the original vector. I think that's correct. Because if you add projection rejection, then you get this vector, I think. Because that's literally, I think that's the definition of adding vectors. Because that, you know, Pythagoras theorem and all that kind of stuff. Right, just turn the music down again. So, is it too loud for you guys? I feel like it's always too loud for you guys. I don't wanna, the last thing I want to do is like have music blasting and you guys can't hear anything I'm saying at all. Vector projection, vector rejection for the vector projection. Where is, what am I trying to do here? Projection, we've got projection. Yeah, we need projection in mine. Oh, I've already done that. Yeah, let's do parametric lines, I guess. Let's get back to parametric lines. And then foundations. The volume is too low. Oh, okay. Cool. I actually want it higher anyway. Yeah, that should be better. Let me know if that's too... I'll turn it up just a touch. Well, paths can store can store the picture files in a global directory like a web, or you can create a note hierarchy where each note has its own folder encapsulating its own assets. There's a real good Obsidian plugin, Excel Draw. Given you are doing vectors, it might be useful. Ah, here's a blackboard basically. Okay, yeah. So yeah, thanks for that piece of information. The way I've ordered them is I have them in. I put all my notes in one folder, and then I kind of just link to them. So the whole idea is that I really aggressively use the idea of this is my like main. Going to drink some tea. Wise choice there. I very much use this idea where I kind of go from one thing to another. So that's why I don't mind everything being flat. It is cool now. Hell yeah. So vector rejection. Anyway. Vector rejection, and then we want to grab the final note, which was the... Okay, I haven't finished that, so I'm not going to put an unfinished note in, but that's good. Okay, so I'm just going to read this anyway. So if you go to find the distance, smallest distance d for a given point A, using the parametric line this, to make things easier, we define another vector which is calculated by A minus the beginning of P, where P is the origin of the line, yes. So D is equal to the magnitude of the rejection of U and V, which is the original vector, which corresponds to the line. So that is the... So it's a... yeah, so the projection matrix... sorry, yeah, vector projection minus the... I believe... length. Anyway, simplifying the terms corresponds to taking this. Yeah, just take the square root, and then we get the actual distance. I think there's more to this, so I'm just going to leave that there. But that's basically as far as I wanted to study anyway, because I needed to make sure that I remembered my maths. Otherwise, there was no point in studying it at all. Yeah, so our graphics theory is getting pretty chunky now, which is nice. So yeah, I'm going to take a quick break, go to the loo, and we're going to go and start aggressively coding. Well, not aggressively, but, you know, coding instead of trying to get billboards working. So we just need something always facing the camera. I think to do this, we need to... excuse me. I think to do this, we need to disable the player and only have a free-floating camera so we can actually see things happening. Billboards, then what we're going to do is make sure that we can integrate billboards without too much issue. I don't want to make another graphics pipeline for this if I can avoid it. I would like to use the 2D renderer, but we might not be able to because of shader objects. Because we need a different shader object type. In fact, maybe I can get away with doing the same shader. I'll think about it. I'll think about it. This is the... yeah, we're going to try and... I've got a bit more brain cells today, so I might be able to figure out like how to load in the 2D renderer with billboard data as well, and then kind of switch between them based on some flags. I don't know if that's going to be efficient, but we'll see. Because what I could do is just build a, you know, a billboard version and a non-billboard version with two different vector positions worked out based on a flag variable that we can send in, which is just going to be a number, and we can just do some bit shifting around to, you know, that's just a bit mask I think we might do instead of having a whole new graphics pipeline. Because if I can get away with just using the same graphics pipeline, that means booting up time doesn't get any longer. I think it's worth trying to get that to work. Over just making a new shader and a new graphics pipeline, which is going to be easier, but it's going to be kind of a pain. The downside of what I'm suggesting, though, is I'm increasing the complexity of the shader and adding some if statements in, so it's not branchless. But I don't think that's too important, considering it's a 2D renderer, and I think this complexity is relatively simple. It's definitely going to be less complex than the fragment shader. Which has kind of like its own way of checking if something exists or not. So yeah, that's what I'm going to be doing in a minute after I've come back from the loo. Feel free to have your own opinions. Again, we're going to use the professional graphics of a professional streamer, Notepad. And yes, I'll be right back, guys. All right, see you in a minute. Yo, we're back at it again. All right, what are we gonna do? So first step, if I want to use the same shader, I've got to have a flag, and I think I'm gonna have a 2D flag versus a 3D flag, because I don't want to overload them immediately with a. What I'm trying to say is, if I want to have a flag, right? So something like billboard flag. Would be, I don't know, something like this. Or... And... UI flag or something. Not Billboard UI. And then it would be kind of like... And then... Oops. Kind of like this. And then obviously it keeps going. That's what I'm thinking anyway. And then we basically go, okay. Based on that flag, we do something different. We have a 2D render at the moment. So we could have like 2 different 2D renderers, right? One's physically based, one isn't physically based. I see a book in the description, Foundations of Game Engine Development. Is that the book you recommend? A C++ Vulkan book, I assume. No, that is a maths book. That is purely maths. I forgot to remove that from the description. That was 2 streams ago. So that, if you're interested in learning that book, I'll just go over what that is. I think I said this earlier, but that's completely chill beans. I think it's actually here. I know that's the actual book itself. So yeah, it is a foundation. I have to go on, you know, private mode because I'll dox myself if I don't. Foundations of Game Engine Development, Maths. So this is the guy, and as you can see, it's got vectors and matrices, transforms, geometry, advanced algebra, which is just geometric algebra. It introduces them as Grassman, projective, and then it kind of brings them together with geometric algebra. Kind of brings them all together. If you want to get better at, like these are used all the time. These algorithms are used all the time, and the way he kind of breaks them down in this book is actually quite nice. I think it's quite digestible as well. It's not that long. And I think if you don't know this, I think it's good to know. But it's a bit of... I don't know how advanced you are with mathematics. But yeah. When are you switching to physics? When are you switching physics to Box 3D? Ooh. Box 3D. Is that a thing? It is expensive though, you know, but I don't know. I feel like all the books are. I don't know Box 3D was a thing. Let's have a look. I liked it when I read it. Announced this week. Ah, okay. Initial release 2 days ago. Okay. Cool. Did not know that existed. Wow. Okay, there we go. Very nice. Yeah, this might be an option to anyone who's starting out. I'm going to stick with Jolt for now. I don't think there's any reason to change. It's not too hard to use. But yeah, that's cool. Did not know that. Replay features seem pretty good. Did you git clone KTX library for Vulkan? Or is there some other way of downloading it? No, I have not used it yet, but I do need to use it. That's not saying that I wouldn't use it. Could make debugging nicer for physics. Makes sense, yeah, makes sense. I think it will help with numerical imprecision, where things get out of hand. Alright, so let's start digging into billboards, eh? So what I want to do is carry another piece of data in my scene, I think. I just need flag in here. It's actually quite easy to do, so uint flag. I just hope this doesn't destroy this, but we'll find out. Oops, what am I doing? How did that happen? So yeah, what I'm going to do is... Do you read graphics books? Yes. I was thinking of reading Ray Tracing in One Weekend. It has 3 books by Peter Sturley, if you know that book. I've heard good things. It's definitely an easier way to get into graphics than learning like Vulkan and then like having to learn physically based rendering straight off rip. That is purely the stuff you'll learn in there is just so you're aware. I'll teach you this one like thing about graphics. When you're learning graphics, when you're learning just graphics and you're doing ray tracing, you'll have to be aware that ray tracing is not the same as raster graphics when you're rastering. So when you're doing ray tracing, you're not rastering, and rastering is what we use for like runtime graphics, if that makes sense. But ray tracing is getting more and more used in graphics techniques. So it's good to know. Basically, I'm telling you that, but it's not. What I'm saying is that the skills that you learn with ray tracing in one weekend won't apply immediately to game engine stuff that you might end up doing in the future, but eventually they will, right? It's like a delayed thing, so it's not necessary. It's like it's advanced in typical game runtime game engines, but that book, the ray tracing in one weekend, isn't advanced, right? It's actually quite easy to do. So yeah, I do recommend that book if you do actually just want to strictly do graphics and you don't want to do Vulkan or OpenGL or anything like that. So it's not necessary. On how to Vulkan tutorial, it was listed. I thought it was necessary for starting. It's necessary for starting Vulkan. If you want to make a Vulkan renderer, that's how I would start learning Vulkan. If you just want to learn graphics and you don't care about what API you're going to use, then I would say you don't have to start with how to Vulkan. You can start with anything, honestly. You can start with learn OpenGL, right? I will have to dive into programming in a minute. I feel like I've turned into a bit of a advice giver stream, but I don't mind. It's my fault if I say that, by the way. It's not on you, anyone, for asking questions. Like, if you want to learn OpenGL to do graphics, you can do it this. It still teaches basically the same stuff at the beginning level. Some of the maths isn't as correct as I would like it. But anyway, it's like what you wanna learn, what's relevant for you. Like a roadmap for you would be very different from roadmap to someone else. So yeah, like I said, ray tracing in one weekend is a great resource if you just want to learn graphics and you don't want to learn API stuff, because it's API agnostic. There's no Vulkan, there's no OpenGL, but if you want to learn how to do those things, you've got to start somewhere. So that's what I would. So that's why That's why I'm not saying don't do ray tracing. I'm just saying, like, if you just want to do graphics, that's a great book to do. Hey, did you see the release of Box 3D? No. Someone has just told me about it, Emo. Which is really cool. Yeah, literally. I want to learn how to use Vulkan or one of the abstractions like GL, as I said. So yeah, I need something to teach me more advanced 2D drawing. Okay. So yes, you've got to be aware that you're going to be learning ray tracing, which is not anything to do with that. That's not 2D drawing. Is going to be very raster graphics. It's raster. You're going to be using the rasterizer, right? So if you want to learn ray tracing and graphics, very like how graphics works, that's fine. If you want to do 2D, that's probably not where I would start, honestly. But again, if you learn stuff, you'll thank it. Nothing's a wasted effort, by the way. So yeah, it's a lot of the tutorials are all 3D though. So that's all I know, really. I can't really tell you. So if you want to learn Vulkan, how to Vulkan is 3D still. The Hazel game engine series is good for maybe 2D, but that's OpenGL and it's pretty old. It's hard to say like what would be a good thing to do. I was asking about how to Vulkan. Do I need all the libraries? Oh, that is listed in the following tutorial. Yes. If you want to do things what I would call the air quotes correct way, KTX textures are like a way to reduce memory overhead. So that's why it's recommended, right? I'm going to end up using that library eventually. I just haven't got around to it yet. what it's setting you up for is like how to do things professionally. Because of that, but because of that, it's harder to kind of get everything working together. So hopefully that tab. Sorry about the lack of understanding there on what you said earlier. Hopefully that helps. Yeah. So yeah, let's dive into what is it called? Billboards. So I want to have this flag variable, and then we're going to go into. Let's get some water. So hopefully everything's cleared up, everyone's understood. Yeah. Yeah, just to clarify, ray tracing in one weekend is teaching you how to do ray tracing, not raster-based graphics. But it is going to still teach you graphics. There is a crossover. All because this. I'll just finish this. I'll finish this off. It is important. Why is this important? This is an incomplete thing. When you're doing stuff in 3D, you're trying to solve this equation. 2D is different, but so it doesn't matter how you go about it. There are multiple ways to solve this equation. This is called the rendering equation, right? It all comes down to solving this quickly at runtime. So if you want to do 2D, you can simplify this dramatically, because you don't have like angle of incidence, you don't have the instant light reflectance, so you don't have the reflectance. You don't have to do BRDF. You can do something much simpler. You just have to deal with like how light bounces off 2D things, which maybe just you can just color that in with a texture, right? You can just fake it all. 3D though, you have to deal with this because 3D is 3D. 3D is harder. But at the end of the day, everyone's solving that equation. Everyone's just solving that equation. That's called the rendering equation. I need to have a reverb button on that one because it's a pretty big beast. Anyway, so let's dive into the next thing. So yeah, I know. Unfortunately, I know graphics is a confusing topic. It's not really accessible. Unfortunately, it's in the same way like say something like learning how to code a website is, because it's like. Yeah, depending on what you want to do, you do different things completely, right? Like building a tiling engine is 2D specific. And like maybe, you know, physically based rendering is only 3D specific. You could have a 2D one if you want, but it might be overkill. You know, there's like, it's like, so what should you learn? It's kind of tricky, right? Ray tracing on one weekend will teach you ray tracing and graphics, but not how to do raster graphics, raster-based graphics. If you need to learn Vulkan, where's this struct? If you need to learn Vulkan, then you need to learn Vulkan, not. So uint 32 T flag, right? So it's very tricky, right? So when I initialize this. When I set this up, so yeah, it's a tough one. A lot of resources, but no guide. How do you know? How do I do not know what to read or do after C++? Yeah, it's tough. It's that's why having a mentor. If you ever get a mentor, by the way, hold on to them for dear life. Mentors are the perfect type of relationship you can build with someone who they will guide you through this stuff. Mentors are OP in life. I want a mentor, by the way. I don't have one. You don't have to have a mentor, but if you can get one, my goodness, it is OP as hell. So what I want to do here is set this up in, so start a project. That'll help quite a bit with knowing what to focus on. Yeah, TT's spot on there. Actually, where do I want to put this? I 100% agree with that. If you even do ray tracing and you find out that it's not related to what you want to learn, like you'll have some more understanding about everything in general. So so we have flags here. So how do I want to set this flag up? So I initialize the 2D renderer. I guess I have to say if it's billboard or not billboard. The problem is, do I have 2 renderers now? 2 2D renderers, and I have multiple renderers per. Yeah, I think that makes sense, right? It's kind of strange to say it this way, but I'm just gonna have more objects per rendering type. So what I'm gonna do is maybe I'll set this as an enum. Actually, that might be easier. I feel like I've got too many enums, but this is gonna be the type of renderer we want based on an enum. And then we can basically build that up. I think that's what I want to do, yeah. Renderer type 2D. This is, again, this is why I really struggled with this idea of making a guide. It's like, you know, if you want to work in movies, then you'll have to do ray tracing. If you want to do a 2D renderer, then you have to do this. If you want to do a 3D renderer, you have to do this. If you're new to programming, you have to do this. If you're not new to programming, you have to do this. It's like all very individual specific. So we want billboard. Oops. But hopefully I can at least help you guys out a little bit. I don't have all the answers, but at the very least maybe I'll be able to send you off in the right direction. I pray I'm being useful in that way sometimes. Because like I said, my dream is to like get you guys better than me. That'd be super sick in my opinion. I think I've talked about this multiple times, so I won't go into it, but yeah. I think, Kalia, you're doing fantastic with your C++, by the way. I would personally continue on with that, despite feeling maybe a bit lost. Alright, cool. Yeah, you're doing fine. Yeah, I wouldn't stress too much about it at all. But yeah, this is why mentors are killer. Like, honestly, straight up. They get you ahead so much faster if you can find one. Like, super OP. Okay, so I'm going to say Billboard 2D. Okay, let's just say everything's 2D, just so we don't get clashing. Otherwise, I'm just going to end up with a silly billiness. Right, so flag comes in here, scene. Now I can go into when I set this up. Yeah, it should be. I think in my personal opinion, I think it should be your priority. You're getting to the point where I think I don't know how, because you're taking your time and taking notes. You could probably pass a junior interview. Because I know how slow you're going and how methodical you're being. I think if you asked you questions, you'd be okay. You've actually already helped me out once or twice on stream, so I can already see your skills are developing. Yeah, so just keep up with it. Okay, so what I want to do here is say this is UI. And for the game one, I'm going to say your billboard. I don't think we even use it, do we? Alright, so first thing, now we've done that, is I want to see what this breaks, because I feel like it's going to break the... Yeah, I've talked about this like on a completely different community. I think rivals and mentors are underrated if you can get either one. Get rid of static. OP. Yeah, no problem. OP relationships to have. Let's just count. Oh dear, this should be out. Let's count. There we go. Okay, that was a mistake. Okay, so we didn't break anything, thank goodness. Alright, so now we need to basically, in our 2D render it to two different things based on the flag. So if we have... So this is perfectly set up for 2D renderers. This is the only... What do I need to change here? This. The only thing we care about is this. This is the pure 2D renderer. And I think also I need the other type as well, I guess. You also need the other data. Two months ago I passed a Python interview easily. Hell yeah, brother. That's really good news. Do I want the view projection? Yeah, I gotta have both, I think. View project. Okay, so I've also got to put that in. My thingy. And change these to S. And yep. Cool, cool, cool. Where does this get set? Okay, so obviously draw quad. Other languages are easy now, such as Kotlin. Fantastic. Yeah, let's change the music. I've had this so many times. This song. Let's go with one of the best. Such a good track. Turn it up just a touch. That's my Windows noise. I've not been timing myself at all very well. Never mind. Isn't the orthographic a projection matrix though? Yeah, that's what I'm kind of thinking about. I'm like, do I want to how do I set this up in a way that has yeah, they're not out. No, he hasn't made them. Those books. Yeah, I'm trying to think. So yeah, one's maths, the other one's graphics theory. And the next, well, the next three, the other one should be graphics theory as well. I don't know when he's going to make them. It hasn't been it's been a while since he's made the graphics theory one. Fortunately, it's all basics. It's not like super advanced, so it's not like cutting edge stuff that is now out of date. If you want, yeah, I don't know. There's so many books out there that you could use. You could, if you don't want to use volume 2 of his book, you can use real-time rendering. If you type that into Amazon, it's got a stormtrooper from Star Wars on the front cover. That's another one that suggests that does what volume 2 is supposed to be doing. Okay, so if you just want to learn graphics theory, again, that's all graphics theory. It's not Vulkan. Yeah, if you're based, you start with the Knuth's Art of Programming. Yeah, I've actually seen them in real life. Yeah, someone had them on the bookshelves at work. They are intense, like immediately difficult. Like it talks about like it rates problems from 0 to 50. I think it's 10 to 50. I can't quite remember. And it says like yeah, yeah, the difficulty of Fermat's last theorem is a 40 out of 50. So if I ask you to do that, just be aware that 40 out of 50 is proving that Fermat's last theorem. I was like, huh? That's not the hardest? What are you talking about? I was like, okay, this is too advanced for me. Oh my goodness. It is a Bible. So what I want to do here is, based on the flag, I guess, I want to set them up differently. Orthographics projection. So if I update the camera, this is pure 2D camera now. So I need a 3D camera for this one. And I just then need to make sure the position is always facing the camera based on its model transform. Yeah, that's why he's the GOAT, yeah, straight up. Knuth is, yeah, so smart. It's like, intense how smart he is. So I think what I need to do here is... or... yeah, okay, so I'm going to have to do, like... this isn't ideal, but... so if... scene 2D, I guess... dot flag is equal to UI 2D. Then do this, else... we want to update the camera via the standard update function, and then just take the view projection, and then add them to that. Yeah, I'm not going to lie, that did put me off reading the books. I thought volume 4's out. Isn't it volume... hang on. Let me look it up. I've got to go into incognito mode. Cars, it'll dox me. Auto programming. Yeah. So yeah. It's 1 to 4. Yeah, that's the one I saw. At work. Yeah, it's up to 4. So maybe 5 is the one you're talking about. Good old Donald Knuth. Yeah, this is the most anti AI vibe coder book of all time. Considering how difficult it is to even, like, I don't even know. Oh my god, that's loud. Yeah, because, you know, vibe coding is all about what I want now. I want it all now, you know. I want this. I want everything now. I don't want to have to wait or listen or learn. Because like Knuth's like, you must learn. Foundations is just the beginning. Right, okay. I think, not that anyone respects, I feel like people don't respect Bill Gates anymore, so this is not really relevant, I guess, but I remember Bill Gates saying that if anyone can prove they've read those books, cover to cover, all 4, he'll hire you on the spot. So what I want to do here, I guess, is... Yeah, what I'm going to do here, actually, is maybe just set everything up as an identity matrix and just see how we go. We'll see, we'll see. We'll see if that's any good. And that might kind of break everything. So, scene graphics, and then just kind of these 3... ortho, view, project, GLMs, mat4. Yeah, so we just set these to identity so it doesn't make a mess. I don't think it's going to be too expensive to just copy some 0s and 1s. Yeah, GTX came out earlier, did. Well, we'll see. I don't know if volume 5 is what people want. But honestly, it's not an easy read at all. Well, I think it's by design, to be honest. So yeah, okay. So let's see. I think that nothing should change from that. Oh, hang on. I don't think I've set this up in the shader. Oh, have I? Right. Okay. So raised up to volume 7. Oh my goodness. Hi, Dimitri. Ah, okay. So volume C and D are still unreleased. That's what you're saying. Right. Yeah. So what was I looking at then? The art of programming, yeah. Well, I'm getting just way too distracted this stream. I need to, like, hit myself on the back of the hand every time I do that. Yeah, I'm good. Thank you, Dimitri. We're just working on billboards right now. So that means we need to set up our model matrix for billboards needs to be set up differently. Yeah, I was just hoping that I didn't break everything by removing that from the scene, because that's kind of awkward otherwise. So that's just the camera position, and now I want to set up a model. It's the quad position. Yeah, so let's see how to do this. Where's the transform calculated? Add quad, right? Okay, so now we need to. So add quad is for UI, really. Let's just adding quad. What we need to do here is, I believe, what we want to do anyway is make a new function where we have the cameras transform as the rotation matrix, and then that's kind of chilling. That's as far as I'm aware what we need to do. So in this case, we kind of need I think 2 different functions, kind of doing the same thing, but a billboard instead. So not instead of add quad, add billboard, I think. Yeah, so I'm going to do that. As soon as I walked in to see you, my air siren started playing. Is that you? Yes. Hopefully that's nothing serious. No, it's not me. Maybe because the stream is so hype. Add billboard. So yes, we're just going to add billboard baggins in, and then. Now, obviously, this is going to kind of... I don't know what this would happen if you use the different flag here, but I kind of don't care. The thing is, if I end up using this API wrong, then it's my fault, you know? I don't want to guard against stuff that... You know, I don't want to guard against... Oops, every single usage of, you know, my API. Okay, so position. So all we need basically is, I think after scale we just want a rotation, right? So, and to get that we want a, what are we using here? We're using, I think when I did this in, let me look at my GLTF. Oh yes, I've been addicted to this song recently. So we want GLTF loader. This is when kid games were really difficult. So what I'm looking for is the local matrix. When I work this out, how do I do the rotation? Yeah, okay, so I do a quaternion. I like old games, yes. Game Boy, that's sick. Yeah, Game Boy, especially 4-bit. Yeah, 4-bit creativity. This is what I would call, because I'm from the UK / Europe, Mega Drive music. Yeah, love it. Cameras. So cameras rot, right? So it's... Yeah, I was playing it yesterday when I was getting everything sorted, you know, after stream. I don't want to torture you guys, because sometimes I've got this bad habit, well, not bad habit. I like to listen to like the same song over and over again for hours at an end. Yeah, so I won't do that to you guys though. Let's turn this right more or less back down. Yeah, so I've added like some of this cool music. I used to play like Mega Man 2 like to death. But I never played Mega Man 3. I was never interested. I just wanted to play Mega Man 2 over and over. Don't know what that was about. Okay, so let's build up the transformation matrix. So yeah, here's the difference. Here's the big difference. Maybe I could do a... Actually, I think I'm going to do something... No, I need the camera's rotation. Do I have access to the camera here? Yeah, I do actually. Yeah, let's do this differently actually. I've changed my mind. Because what I can do is get the camera's rotation out of the camera itself. And then this simplifies. Then I actually end up using the same function. But it does two different things depending on the state of the class. So we're in state class, so if... This will just make things less. This might be bad, I don't know. I haven't quite decided yet. Yeah, I'll do that for now, I guess. Oh, I like, yeah, Game Boy Pokemon's sick. It's just a vibe. So what I want to do here is... So soon I am going to get a video because I'm getting hungry. Oh, this can't be const now. Okay. This can't be const. Never mind. So we're just signing it after the fact. And then if I've written a basic breakout game in Game Boy. Yo, nice! It was hard. I have so much respect for people who actually wrote things as complex as Pokemon. Yeah, I mean, there's some stories that are just like mind-blowing. Like, the guy in Pokemon... I know you're talking about Game Boy, but in the Game Boy Color one, Gold, Silver, someone had to save... This is what I remember. Like, one of the lead programs had to save the day. Because that was coming close to release and it like barely worked because it was like too much data, but they got the data so compressed and so well done after like the guy crunched like crazy that they could add Kanto into the game as well. Like they could add like an extra basically part of the game because they did so much compression. So having a function relies on outside state is fun until it isn't. Yeah, this is the thing. I don't know if I'm just about to make the worst mistake ever. But I also just don't want to make things like so convoluted. Yeah, I think you're right. I'm willing to go back on this decision because I'm not really confident in it, to be honest. It was just like an idea I had, and I was like, wait, I could do it differently instead. So let's just do billboards. Same thing, but yeah, because I don't want to lose functionalities. So add billboard. Yeah, I'm fine with doing 2 different functions because effectively this is what I'm doing anyway. So we're gonna have a lot of repeat yourself situations though. It's the only downside of doing this approach. I don't think there's a really like correct option, but at the same time I don't want to have to remember things correctly, if that makes sense. So obviously this is non-textured, this is textured. Right, so what we need to do here is get the camera. The downside as well is the draw quad. Okay, so what I'm going to do here is take this out. Maybe I should make another... I feel like I'm getting to the point where I'm going to make another class here. Yeah, I'm going to make another class struct thing. It's going to be a bit basically the same thing, but it's... Yeah. No, I want to use the same... The reason I'm doing this... Let's say this out loud. I'm trying to avoid having multiple graphics pipelines. I want to use the same graphics pipeline. And if I have like basically the same graphics pipeline twice, with just no changes at all, it's going to take longer to boot. So... C++ subtly hints to use types in this situation. Yeah, only clean code. Match 4 lines per function. One function does most. one tenth of a thing. Yeah, it's difficult. This is why I'm trying to like find the best decision based on one graphics pipeline. Because if I can just reuse the same... Hang on, if I make 2 instances, I've kind of made 2 graphics pipelines anyway. This would only work if this was global, right? Alright, maybe I need food. Alright, so I'm going to get some food, I think. Because I'm legit, like, just all of a sudden very hungry. What was I watching? Just finance videos... mangoes, no, atriarch. Let's pick something that's like relevant to the stream. Yeah, I'm getting a bit bleh. I don't know. Would this benefit us to go over some of the maths? Or shall I put on an AI video? Fuel is running low, definitely. Yes, let's do that. Whatever you said there. Ace rollers. Yeah, because we're going to be doing that anyway, so... Compute particles. Very good suggestion there. I don't know. I didn't know that existed. Hell yeah, brother. Okay, so it's half an hour. We probably won't finish it, so maybe we'll watch the rest next time. So we'll watch this in 2 parts. They've just had to remind me this is a... I don't think you need clean code maximize, but that's the trick, to use code. Got you. Okay, I'll reread what you said there, Dimitri, after I've eaten. Yeah, my energy level's like bleh. So yeah, this is a perfect... Right, let me just let him play so I can hear that his...
use of age-old PlayStation IPs.
He's still
the
very
game
quiet.
features numerous novel particle systems, taking full advantage of the PS5
Gets a bit
hardware to dump
loud.
as many particles on screen as possible. There's also the game Dreams, which is made entirely out of particles, and my personal...
Right, that's about right. Okay, you need to compress things. Fantastic. That'd be good. So I'm just going to grab my lunch, and then we'll watch this. Let's just get it out of the fridge. More salad. More salad. What want to do? I might have to get extra food. I'm super hungry. It's funny, streaming has helped me lose some weight, which is kind of, I didn't mean to happen. Alright, okay, so I'm just going to head to the loo as well. I just stood up and needed the loo immediately, so I'll be right back. Back. Right, so we'll watch this. Yeah, fantastic suggestion. Because we need to get better at this anyway. Right. Let's put this here. Start a lovely timer. Studying. I need to fix this timer. It's all over the place. So yeah, just gonna watch this again for the people who are new, who may be watching or lurking or something. Because I don't want because I don't want it to put you through chewing and cutlery rattling and all that kind of annoying stuff. I'll go on push to talk, but you know, feel free to ask me a question. You know, you can still talk to me, but I'll just be a bit slower to reply while this is on. Okay, let's enjoy.
Hello everyone! Astrobot has taken the world by storm this year with its tasteful use of age-old PlayStation IPs. The game features numerous novel particle systems, taking full advantage of the PS5 hardware to dump as many particles on screen as possible. There's also the game Dreams, which is made entirely out of particles, and my personal favorite particle system, the humble fungus spores from The Last of Us 2 that float around in the air and reflect light. All these examples are from newer games, so why is it that novel particle systems are a recent phenomenon? What makes a particle system a particle system? How many particles can my GPU even draw? All of this and more in today's video, where I explain how I accidentally invented a particle system that no one has ever seen before. So like, what actually is a particle? This question kind of misses the forest for the trees. The definition of a particle is very case by case and depends on the context of all in which it lives in and came before it. What really matters is the particle system as a whole. Take for instance a forest of trees. We could say the forest is the system and the trees are the particles, or a swarm of bugs. The swarm is the system, the bug the particle. It then makes more sense to describe what a particle system is. So I would define a particle system as a collection of entities that all follow the same or a similar set of rules. This means we could call something like Ghost of Tsushima's foliage a particle system, where all of the individual grass blades and flowers are particles because they all behave the same for the most part. Particle systems go beyond physical entities though, and are a driving force of visual effects in video games, such as the iconic Zelda Wind Waker bomb particles or infamous Second Son's novel particle effect system to make the powers as cool as possible. This brings us to the inspiration of today's project. Imagine a point in space centered at the origin. We split this point into 3 new points, where the first point is going to be divided by 2 and move towards the point 0, 0.36. The second point will also be divided by 2 and move towards the point -0.5, -0.5. The third point will also be divided by 2 and move towards the point 0.5, -0.5. And then we repeat the process again with each new point, splitting them into 3 and doing the same operations, and so on forever. Repeating this process an infinite amount of times gives us the very famous Sierpinski triangle fractal. Very surprisingly, from just 3 simple instructions, a world of infinite detail is born, which had me wondering, what happens if we added another position to move to? What if we divided by some number other than 2? To realize this idea, I decided to make use of a particle system to model the shapes created by these instructions, so let's start by learning how GPUs can draw millions of points with ease. But first, something a little different. I'm so excited to announce the channel's first merch apparel, Professor Love for the graphics processing unit with the exclusive Acerola I Heart GPU shirt, available in the US and the EU. I've been struggling to afford spending more time on videos to create cooler and more interesting projects like the one in this video you're about to see. So if you would like to see videos on deeper graphics programming topics like terrain generation, fluid simulation, path tracing, physics simulations, or whatever else, please consider supporting the channel and buying a shirt so I can continue creating free educational resources for graphics. To reiterate the goal, we have a shape that can be created from an infinite number of iterations on a set of positions. In order to render this shape in a game or something, we obviously can't do something an infinite amount of times, so we are instead going to need a very large number of particles to approximate that infinite series and by extension, the shape. The problem here is that drawing millions of objects can be quite slow, and we want to have at least 60 frames per second. If you remember from all the way back in my video on drawing millions of grass blades, you might think the solution to this problem is GPU instancing, because that's what made the grass possible. So let's start with that approach. When we want to render an object in a graphics engine, the CPU dispatches a draw call to the GPU. This draw call contains the information the GPU needs, such as the mesh to be drawn and where. This draw call is then added to the schedule of actions the GPU must take before the next frame is rendered. This is totally fine in most cases, and how it works for the majority of objects in a scene. Each one has its own draw call. A major problem arises with stuff like foliage though, where there are lots of entities. In the case of my original grass field, we would be looking at something like 20 million draw calls, and thus 20 million scheduled actions for the GPU to take before the next frame is rendered. The GPU will draw this blade of grass, and then this blade of grass, and then this blade of grass, and so on and so forth until the whole field has been drawn. The sheer number of scheduled actions will tank the performance of our game to 0 FPS, and we no longer have a game to play. If we pause and think a moment, we would realize that the GPU is drawing the exact same mesh just at different positions, so it would be convenient if there was some way that the GPU could interpret our 20 million draw calls as only one and draw all of the grass in one fell swoop. To do this, we supply the GPU with the mesh to be drawn, the number of times it should draw it, 20 million in this example, and then an array of 20 million positions to draw the meshes at. Now, instead of a draw call, we would call this a batch because it's one scheduled GPU action that results in many draws, replacing the 20 million calls from earlier. This is known as GPU instancing, and it has a number of limitations. The first is that the mesh must be the same for all instances. This is because to make GPU instancing possible, we actually do the simplest, hackiest thing ever. In the vertex shader of the mesh, we supply an instance ID to the shader and use that to index the buffer of positions, which we offset the vertex with. Technically speaking, we are drawing all of these instances at the origin, but after we grab the corresponding position and offset the vertex, it shifts over to where it's supposed to be. Secondly, the buffer of positions cannot be efficiently updated from the CPU at runtime because of data latency between the hardware. 20 million positions from the CPU would crash our game to 0 FPS, and we would no longer have a game to play. So, thinking about our dilemma of needing millions of particles, GPU instancing sounds like a proper solution. It's certainly going to be faster than millions of individual draw calls, but we need to consider how the limitations of instancing will affect our particle system implementation. First, all the particles must be the same mesh. We could use a cube, a sphere, Leon Kennedy, or a triangle, but when most people think of particle systems, they think of point clouds. A point cloud is a collection of points which occupy exactly one pixel, The mesh is only one vertex, no triangles or anything. So this means we will be instancing a mesh of just one vertex, and the batch will result in a point cloud approximation of our shape after all the instances are drawn. The second limitation, that we can't update the positions of the particles from the CPU, is a bit upsetting though, as ideally we would like to be able to move the particles around at runtime. Thankfully, we can make use of compute shaders to operate on GPU memory directly, enabling us to update the particles as much as we want. This is the main reason why cool particle systems have only been popping up in the past decade or so, because compute shaders and the ability to operate on GPU memory directly is a fairly recent technological advancement, whereas previously, particles had to be controlled CPU side. So how can we most optimally utilize GPU hardware to generate a list of positions from the set of instructions I described earlier? Returning to the real topic at hand, we have a set of 3 functions that we want to repeatedly apply to an ever-growing set of positions. In math terms, this is called an iterated function system, where the next output is dependent on the previous output. In GPU land, the word iterated should raise some alarms, as GPUs are meant to do everything in parallel, not in sequence. Let's ignore this red flag for now though, and continue onwards. The base case of our system is a point at the origin. To progress the system, we duplicate that point 3 times and apply each respective function. Then we duplicate each of those points 3 times and repeat until we're satisfied. I'll be referring to each sequential iteration of the system as a generation. The first generation contains 1 point, the second contains 3, the third contains 9, and if we continued, a 4th generation would need 27 points. For those of you with computer science
Sure thing, Heisenberg. We can just do that real quick. Let's see if it runs. It's the same as yesterday though. We are trying to get things to work though. There you go. Same as yesterday. But we are doing stuff. I just haven't finished. There we go. Yeah, back to the video. I'm currently eating Heisenberg. Completely fine. By the way, you didn't know obviously. So yeah, it's this is really interesting.
Experience, the alarms should be getting even louder now, because this is exponential growth. The amount of points we need to represent a generation of the system is 3 to the nth power, where n is the generation. If you don't have computer science experience, all you need to know is that exponential algorithmic complexity is about as bad as it gets, demonstrated by this deep red color on the complexity graph, describing it as, quote, horrible. This is because the number of particles we need is quickly going to get extreme. Just 16 generations of the system requires 43 million particles to represent it. Even worse, we need to visualize all generations to get a filled out shape, so our memory cost is going to be the sum of 3 to the n. 16 generations would require a buffer of 65 million positions. As far as we know, we just have to bear the burden of this cost, so let's continue onwards. The good news is that we can easily pack this into a single buffer for our GPU instancing. Now for our compute shader, given a desired number of generations, we calculate the sum of 3 to the n and instantiate a buffer in GPU memory of that size. Since generations are dependent on the previous generation, we must calculate each one sequentially. Our first dispatch will fill in the first slot of the buffer with the base case of 0, 0. The next dispatch will be 3 threads that operate on the base case. The next dispatch will be 9 threads that operate on the previous 3 outputs, and so on until we have created all the generations we wanted. As you can see, the thread count also grows exponentially, which is really bad, as there is a limit to the number of threads that can be dispatched at once. An ideal thread group size is 64 threads, and the maximum amount of thread groups.
Yeah, we're at lunch indeed. Wait, where you at, people? Yeah, good to see you, my man. Just currently eating. I don't obviously chew on camera, so on microphone. So yeah. But we'll currently, if you stick around a bit longer, we'll finish this vid, and we'll get back to trying to render billboards, which would be cool. Yeah. Hope you're doing good, my man. All right. To avoid chewing, I will again. I'm on posture talk at the moment, so so you don't get grossed out. Because I know I find chewing absolutely horrendous to listen to.
that can be dispatched at once is 65,535, or 2 to the 16th. Multiplied by 64 is a limit of 4.2 million threads in one dispatch. That is a lot of threads, but if you recall from earlier, a 16th generation of our system would be 43 million particles, and so we would need 10 dispatches to generate all of those positions, not including all of the dispatches needed to create the prior generations. In the pursuit of a program...
No problem, my man. Well, I'll explain stuff if you want. Just feel free to ask questions.
That runs at more than 0 frames per second, let's keep it so that the number of generated particles can be contained in just one dispatch. With this limitation, we can only create 13 generations of this iterated function system, but that should be good enough. With a buffer of positions created and a single vertex mesh to instance, we draw 2.4 million particles to obtain an approximation of the Sierpinski triangle fractal from earlier as a point cloud. That was a lot of effort to obtain a fancy triangle, and even worse, our algorithm for creating it is about as bad as it could possibly get. If we showed up to GPU land with this, we would be laughed out of the venue and nobody would ever listen to us ever again. Our only choice would be to turn to a life of alcoholism to cope with our failure before dying tragically in a car crash. Hopefully, there's a better way. Wait a second. What even is this shape called? Obviously, it is the famous Sierpinski triangle, something that shows up in many math contexts. But in this case, its technical math term is the attractor of the iterated function system. What we've done to generate this particular attractor is the formal mathematical method that reliably and uniformly creates the shape. You can see that all the points are very cleanly distributed across space at each iteration. As I've demonstrated, this formal method is very inefficient computationally, requires an absurd amount of memory, and actively fights against what GPUs are good at. The Sierpinski triangle is also one of the simplest attractors, requiring only 3 functions, but many more interesting attractors exist of differing function set sizes. The cost of a formal iterated function system is thus k to the n, where k is the function count and n is the generation. Thankfully, this formal method is not the only method, and a better one can exist for our use case. Imagine a future version of our iterated function system that has freely surpassed its computational and memory limitations. Domain expansion. The chaos game. It's incomplete. It's ugly work at best. But for now, that's fine. The chaos game is a stochastic method for generating the attractors of iterated function systems. It works in almost the dumbest way possible. All we do is randomly apply the functions from the set to the positions of the particles, and the points will converge all the same. There is no need to calculate multiple generations sequentially. The entire buffer can now be updated in one single compute dispatch. There is no longer a restriction on particle count based on generation size. The chaos game works on any number of particles. The more particles there are, the better the approximation of the attractor is. The chaos game is an absolute win. It reduces the complexity from exponential to linear, lifts the restriction on particle count so we can choose any amount of particles we want, and takes full advantage of GPU hardware by updating all the particles at once in parallel instead of in sequence. Of course, the shape is now noisy, but there are many ways to fix such an issue. Now that we can efficiently generate attractors, it's time we started generating more interesting shapes instead of just the Sierpinski triangle. Wait a second. Why does this set of functions even result in a cool shape? Looking a bit closer at one of these, x is a 2-component vector, so let's expand each component. X and y are divided by 2, which is another way of saying multiplied by 0.5. These added values here are called translations, which simply moves the position of the point through space. For fun, let's add the missing variables to both lines multiplied by 0, and we have revealed a dubiously unrolled matrix multiplication. This is true of every other function too. We can generalize them to the form ax plus b, where a is a transformation matrix and b is a translation. This combination of a transformation matrix and a translation is called an affine transformation, and it can be represented as a single matrix multiplication by adding an extra row to the matrix with a 1 at the end. This is known as an augmented matrix or affine transformation matrix. Fun fact, when working with 3-dimensional coordinates, transformation matrices are 3 by 3, so an affine transformation in 3D 2D would require a 4x4 matrix. This is why matrices in Unity are 4x4. With this new information, we can rewrite all the functions in our iterated function system as affine transformation matrices, and now when we update our particles, we simply multiply the position with a random matrix from the list. Why would we do this? Because now we are free from the strict definitions of functions, and we can easily slot in different matrices to generate new attractors. But before we can do that, we first need to understand the humble matrix transformation. Transformation matrices represent linear mappings, or in simpler terms, the instructions for moving from one space to another. Consider our usual normal world, where 1 meter is 1 meter. Now consider a different world, where everything is half as small. 1 meter is now 0.5 meters. The map to this alternate world can be described with a scaling matrix. Putting 0.5 along the diagonal will uniformly reduce the scale of a position to our new, smaller world. This is exactly what's happening to our particles. Every iteration, a particle is mapped to a smaller and smaller world. It can never grow larger, and so it always converges to the fractal shape, never escaping. Scaling is not the only kind of linear mapping though. There's also rotation, reflection, shearing, squeezing, projecting, and more. And the amazing thing about matrix multiplication is that you can multiply a whole bunch of them together to create a cooler matrix that does all of that multiplication at once. Keep in mind that matrix multiplication is not commutative, and the order matters. For this video, I will be using scale, rotation, shear, and translation. This is, of course, a ridiculous amount of settings and parameters to mess with for just one affine transformation, and we can have any amount of them in our system technically. So to make our lives easier, let's randomly generate each individual transformation before combining them into a single affine transformation matrix for our iterated function system. Now, every time I press the Generate Shape button, we are met with a new and exciting fractal shape that's a bit different from the Sierpinski triangle. Given the statistical likelihood of these shapes being generated, it's quite unlikely that anyone has ever seen these shapes before, so congratulations on being the first people to see them. Because of the nature of the chaos game, we can easily swap sets of transformations in and out to update our particles without completely resetting the particle system, which is an idea I wanted to explore even further. How could we more cleanly blend between these shapes? On the topic of blending, there are many approaches, and it comes down to artistic preference eventually. Blending values of any kind usually starts with a very simple equation. Given two values that you want to blend, a and b, and a blend factor t, the blended output is 1 minus t times a plus t times b. When the blend factor is 0, b is cancelled out and we only get a, but when the blend factor is 1, a is cancelled out and we get b. When the blend factor is 0.5, we get the average of a and b, or the middle point between them. This equation is known as linear interpolation, or LIRP for short, and is the common foundation for blending anything you want, whether that is scalar values, vectors, angles, positions, colors, or even matrices. On the topic of blending iterated function systems, the naive approach would be blending the positions directly by calculating both attractors and then blending between them. Unfortunately, this requires double the memory, 2 buffers for each attractor, and double the memory fetching when we inevitably blend the two. You might think this at least results in a decent blend, but it doesn't. Blending the positions of 2 attractors doesn't look that good. It's stiff, direct, and doesn't truly illustrate what a blended attractor should look like traveling through space. There should be like rotations and shit. So for double the memory cost, we also get a worse result. Thankfully, because of the chaos game, we can decouple the blending from the positions and instead blend the transformation sets for a better result while still operating on only 1 buffer in memory. We have another problem though. Directly blending affine transformation matrices gives very poor results. Blended matrices look like they do transformations they aren't supposed to, such as this one that is shearing space, even though no shearing transform is involved with the original matrices. So we unfortunately have to take the blend another level higher and blend the individual transformations before they are combined into one. Blending at this level gives much better results. The shear from the naive blend is no longer present. Now when we interpolate attractors, the movement of the particles is far less direct, rotating through space like they should, instead of traveling along a straight line. We have yet another problem though,
Yeah,
which is that linear interpolation is very ugly. It's stiff, with no soul. The traditional solution to this is easing functions that operate on the linear blend factor, making it non-linear so that the blend has more character. An amazing website exists with a collection of different easing functions called easings.net, but since I'm using Unity, we can just use an animation curve. This is really an easy way to instantly make your animations more interesting and less robotic. I was still less than satisfied with these easing functions though, so I decided to implement Freya Holmer's frame rate independent lerp smoothing, which is the only animation method I tried that gave the impression the fractals were truly growing out of each other, and the results are stellar. Conceptually speaking, the lerp smoothing exponentially decays our attractors towards each other, and you can read more about it in Freya's blog post on the topic, in which she also goes into more details on frame rate independence and linear interpolation. The rules of our particle system are now complete. We can procedurally generate and blend between three-dimensional iterated function systems all we want for infinite, never-before-seen entertainment. This is only 1 million particles though, which, to be honest, is rookie numbers, so let's see just how many particles my GPU can handle.
All right.
It's time for a...
That's cool. I think we'll stop it there. That was interesting. I'm glad I've eaten. So let's get back into it. Let's start the music up. Oops, that's not going to build either. Put a breakpoint there. Pointlessly. Right, let me just get the audio kind of roughly back to where it was. So I think you were about 2-ish. And if I was to play... let me just check. Yeah, that seems good. Okay. Just check something real quick. Now I've just got everything set up. It won't take me too long at all. How good of a PC do you have? How good of a PC do you need to get started in this place? You'd be surprised how... It depends on what you want to do. If you want to start doing something that I'm doing, you need less power. If you want to do something in like Unreal Engine, then you need more power. So it really depends, right? Calculator plus 4 gigs of RAM, yeah. Just got a normal laptop, no GPU. You've probably got an integrated GPU. Now you're obviously going to be limited the less... the better the hardware you have, but you don't know anything about game dev, like you said earlier. So let me think. What's the minimum you would need to do? So we're doing game engine development. Just to introduce what that means is we're making our own game engine. So we're not using a game engine like Unity or Unreal or Godot. This allows us to get away with things that we couldn't get away with on those engines. When it comes to hardware, for example. Like, I know it seems this is a trivial matter right now, but if I go to my executable and build, outside of the assets, my executable is tiny. So my assets are huge. Because they contain like assets, like loads of assets I'm not using. So you could say that's unfair, but programs are typically smaller anyway. What I'm saying here is you don't need like loads of storage that you might need for like Unreal Engine. So if you want to do graphics programming, I would say make sure you have at least a graphics card that has the newest version of Vulkan on. So I think if I go, if you bear with me just a moment, I've got a Wikipedia. Pause this because I'm not listening to that video. And I go on NVIDIA. I think I'm going to do with like NVIDIA GTX 600, I think. Oops, not GCC. Because what I'm interested in here is figuring out the Vulkan version supported. So that's Vulkan 1.2. But if we keep going forward in time, I think, yes. So generally you would need a processor, I'm going to say It's at least let's see, so 800 AM. When was this? When did this come out? So I'd say you need a computer at least that's 15 to 12 years old. Generally, if you have a laptop, you should be fine. That's older than that. No, that's fine. It's people ask me this stuff all the time, so it's completely chill. So yeah, that's what I would recommend graphics card wise, because you basically want Vulkan 1.4. 1.2 is fine. But or if you're just going to use OpenGL, that doesn't really matter. OpenGL 4.6 has been supported forever. But if you want to do exactly what I'm doing, which is Vulkan, then yes, you would need a slightly newer PC. So just check with what specs you've got and what that supports. But for simple 3D from the last 15 years, yes, exactly. It just helped you develop stuff. Yeah, GPU info. Yeah, that's a great thing as well. If you go to GPU info, which I have up here, I think. What do I? Yeah, GPU info. And if you just type in your graphics card here, you'll find out. It doesn't matter if you don't have a graphics card. Just type in your GPU. Sorry, your CPU. So whatever that is, on your laptop, and it should tell you what you supported. You know, because they have like, you know, Samsung, Huawei. You know, like they don't just have Nvidia. Something. And you'll find out like what you're working with, depending on your integrated graphics card, which is probably on your CPU. Outside of that, I think Dimitri said this earlier, the hardest part is actually going to be getting good. That's going to be the hardest part, not buying the hardware. That's going to take longer. It's more, so we can look it up. Let's look up Zin's graphics card. So we have a UHD even. Yeah, Intel. What did you say? 620? Okay, it's right there. So yeah, 1.3. 1.3 is fine. Oops. I'm gonna say, yeah, just make sure your graphics driver is up to date. I don't know if you have this. 1.2. Yeah, you would hope. So you don't really have the newest on some of these. So just, I don't know which one you have. But yeah, if it's this, yeah, 1.3 is fine. If you have if you're going to use Vulkan at least, then you should be fine. 1.3. 1.3 is like the nicer version. 1.2 and 1.2 and less are kind of harder to use. Still viable, but if you want to use OpenGL, which honestly might be a good path to go down actually, then yeah, there we go. I think you're fine. I think you're completely fine. The hardest part, like I said, is getting good. That's gonna take that's gonna be more of a worry. Getting good at programming is gonna take longer than worrying about what hardware you've got when it comes to graphics programming. And I can tell you that it's tough. It's tough. That's the hardest part. If you're cracked enough, you can get 3D. You can get a 3D renderer running in a cave from a box on a Pentium. Yeah, exactly. Pretty much tough road. Yeah, but yeah. I'll walk it. Hell yeah, brother. Well, as they say, what is it? I can't even remember the saying now. Yeah, we've got spare jackets. Welcome to the club. You know. Welcome. Anyone's welcome to walk it with us. Walk down the path. Alright, so Billboards. A large part of... yeah, just to set you off on the right path, if you don't know a programming language like C++ or Rust or Zig or something like that, that's what I would start. That's what I would start, honestly. I wouldn't even start with graphics. I would start with learning to code. But yeah, don't worry too much. Just do something that's fun. Learn how to do it, and yeah, and don't go nuts. You don't have to. So yeah. God give me lol. Yeah. All right. Okay. So let's continue on with this. Where are we up to? So we have. So I was kind of umming and ahhing about this, but yes, I don't really care about the solution, honestly. I'm just gonna go with the A solution. I think A solution's better than trying to get the perfect solution, right? The care is unreal here. Yeah. I've said this a lot. People hear me say this all the time. My dream, honestly, is for people in my community to actually be better than me at programming, while I also try and be the best. You know. So yeah, if I can help out, I try. Because that's like real sick to me. That's like super awesome. I actually don't need this. I just need to do it from the graphics card. Yeah, being successful while also you're even more successful than I am. Right, okay, so we want to... So which order? We do... Where's the multiplication? I think we have to do rotation first. I've forgotten which order the order in is. Yeah, that's a really good point there, Dimitri. If you can't handle your programming, then the project kind of dies. Right, let's continue. What is it called? There we go. Okay, so what I'm after is just an order of handling. This, we take in the translation. Yeah, so I'm just going to rob this because GML makes this a bit, sorry, CGML makes things a bit complicated, like a bit awkward to like remember the order at which you put them in arguments. Like function overloads do help with a lot with this. This is kind of so gotta throw that in as a comment. Yeah, so we want to take this, do a const. Let's get the camera. So I want the camera's rotation. Hopefully it's there, just accessible for us. Let's see, what have we got? I think I will actually go back on the update, because that's just going to be really annoying if I have two update functions. But I think adding billboard, yeah, draw quad. So yeah, I'm going to add that back in, I think. Anyway, I'll do that in a minute. Okay, so we have rotation. Please, 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 please. Yay! Woo, 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 woo. So we have rotation. Let's throw this in. Camera. That 2D camera. Nice, 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 nice. Alright. Const mat4. S rotation. Matrix. How's it going? Yeah, not bad, not bad. We're just about to get, I think, billboards working. I think, assuming everything goes well, we'll see. See if it actually goes well. So that should be a valid billboard. Let's put the rotation matrix in here. Oh, we want the camera rotation, I guess. In here, then. Yep. Get rid of these two. Fantastic. And then we can start worrying about how to do particles. Maybe using that chaos thing that was that we just watched. How you doing, Yip Tag? Hope you're having a great day, whatever you're up to. So that's good. Now we just need to update things based on the state. Yes, again, this probably could be designed a little bit better, but I'm not going to worry about it too much. So, oh, my nose is getting itchy. Look at me, always complaining. What is wrong with me? Nose itchy, hungry. Bruh. Anyway. 2D. Then otherwise we want to update differently. Okay, so then we do an update function. The Chaos game seems specialized for those functions. Ah, I see, okay. Right, yeah, I think you're right. Yeah, we're not going to do anything like that. Oh yeah, this is a sick track. Right, okay, so now we should basically have nothing. The problem is this might be completely inefficient in the end. We might have to do this all in the compute shader. But I don't really know. Like, how do you have textured particles? I'm doing great. Last time I forgot to mention I got the chance to meet Trident developer behind the scenes of the Pulsar engine. Yo, hell yeah. It's an amazing project and worth checking out for inspiration. I think I've heard of that before, but let's see the Pulsar engine. I forgot to put the timer on. Jeez, almost like I've done no work. Get up. Well, I'm going to type the Pulsar engine in. Pulse game engine. Oops, forgot the. Have I seen this before? No, I kind of typed in. Let's type it in properly, eh? Pulsar native. Forked from this. Why is there a fork? Hang on. Am I just getting... Hang on. You said his name was... Let's see. Yeah, I don't think this is the right one. For some reason... Yeah, okay. There you go. Try it. Yeah. Tristan. Oh, you said Tristan. No, Trident. No, actually, I haven't seen this. I thought it was something else. Hell yeah. I love it. Next generation game engine that you deserve. Implemented in Rust. Yeah, I'll give it a quick star. Very cool. Yeah, I'm sure it's a fantastic game. Honestly, I've been blown away by some of the engines I've seen because it's nice being introduced to that type of thing. All right, so we have instance rendering. We are doing that loveliness. We are doing a different camera based on that. So we just need to make sure this is in the shader, and then we think we're going to be able to debug things. Oh no. So if I have this flag. Very simply, if... I know it's not ideal, but it's, again, this is a 2D render, so it's not exactly very complicated. So if scene 2D flag is equal to UI flag. For now, I'll just do an else. It's completely fine, I think. So otherwise, it's view. No, project view. I think I've got it right this time. I just make sure because I always make this mistake. So transform. What have we got? We got 2D renderer. No, just go to any shader, dude, and you'll find out. Yeah, it is project first. Cool. Right, now we should have nothing different. Pair draw call conditionals aren't that bad from what I've heard. Cool. It's interesting because it was... So this is what YipTag has said. It's interesting because it is a blueprint like Visual scripting. I see. Features. And it's volume tiled forward renderer. Okay. So it uses. Okay. So it can use GI with that, I see. And they are planning to implement improved versions of Radiance Cascade. Oh, okay. Interesting. I haven't seen that technique used anywhere apart from things like I think it was used in what is it? Path of Exile, yeah. Path of Exile 2. That's really sick. Okay, let's I think we're getting the same songs over and over again. Let's go with this will do. Again, story about this, just for the people who are new. Composed by Tim and Jeff. Apparently there's 2 people, but anyway, one of them was 18 years old and just liked making music for the NES and like made one of the best soundtracks for the Nintendo Entertainment System. Someone described it as like a world-class guitarist going to Chuck E. Cheese to play guitar. It is good. They only released an article a few years back, right? Yeah, I think they did use it in that Path of Exile 2, as far as I were. Path of Exile 2 is still kind of new. I'll have to look at the Simon Dev thing again. Yeah. Yeah, it's a lovely way to get indirect lighting. Yeah, so we'll implement that, tomorrow maybe. Maybe not today, but okay, I'm messing about. Right, okay, so let's put a billboard on the screen. So we have our 2D renderer. Oh, we do have particles. Let's add our particle. I think I do. Hang on. I need to look at my my assets that I made. Yeah. Alright, so we have particles.png. Again, I need to use better compression so we don't end up with a bunch of junk in memory. But we should be able to hopefully see a alpha supported particle thing. So if I go to GPU resource, I think. Oh, we need it in 2B render as well. Hang on. Right, so we duplicate this. Put that there. Not double PNG though. And then we need the PNG. I kind of need to change this. I don't know why it's like this at the moment. Replacing all files. Atlas. UI. For now. Or main menu, maybe. Main. Menu. Alright, so replace all. And now we duplicate this once. So I'll press the D button, not save. Oh, stop it. Particle. Use a comma here because that's not going to work properly if I don't. And now I think we can officially use the 2D renderer. I don't think there's anything in GPU resources, I don't think. To render a particle fake thing, billboardy. Let's see. Game, go to game. We have a 2D renderer, it's billboard, initialized, build game UI, which does nothing. Okay, don't know why the thing didn't work there. So what I want to do then is just to see if this works. So what do we want to do is very simply... Is that for the GUI? Hang on. Yeah, that's user interface. Okay, so it's for 2D renderer. Yeah, we need to pass in... Hang on. This uses a 2D renderer. Now, if I try to add a button... Am I going to eventually crash into the fact that I'm going to have to use two 2D renderers? One for UI and one for imposters. Maybe. For now, this is not used at all. I think it just sets up some stuff that I'm never going to use. Yeah. Alright. Let's... I'm going to comment this out for now because I don't want to have to think about it. Add billboards. Okay, so when I'm doing this, when I set up the main menu, how does this work? Oh, yeah, I'll be in user interface. I'm just going to steal some code. Yeah, this. No, go to there, please. Yeah, so I'm just going to rob this. And why do they have an add button? Oh yeah, because it's got an extra bit of code here. We want to just remove this for a minute just to see. Okay, we don't need these. Okay, maybe we do actually. We do actually want the center for now. Again, it's just mostly to test stuff. So what I'm going to do here is open my thing in GIMP, I think, just so I can see what we're messing with. Can I throw this in here like this? No. Okay, so we should be moving you. I guess not. Right, so let's just go back. I shouldn't have done that, to be honest. Alright. New. How do I... I'm just going to close this, actually. Yeah, we'll save that for now. And then we can open a file. As long as I avoid my homework file, then we're all good. Can't go in there. Right. So we should have textures. We should have particles. Okay, cool. Using GIMP in the big 26, indeed. I'm not really an artist, so I don't really need anything else so far. Obviously, there's like 1,000 different links to make textures, like substance painter and all that kind of stuff. But for now, I just need to make sure. So I want the blue one. So it is 06464. Yeah, you don't want to leak where you studied. That's it. Definitely don't want to leak that. That'd be very embarrassing. All right. Right. So the size of the atlas is why? Hang on, give me a second. What are we working with here? So when I have these, what am I saying? Is there something else, like atlas size or something? I'm confused. So I'm gonna go back to game real quick. Width. That should be height. I don't know why that's not correct. Yeah, we have width and height here. Hang on. Okay, so what I'm going to do is, based on the 2D renderer, I think we can get width and height out here very easily. And now we just need to... Why are you complaining? Yeah, so I need to fix that in... Oh, I see. Okay, that's for UI. Okay, so I'm just gonna build up my own stuff, I guess. So, how big is this texture completely? It's down here. 256 by 256. Okay, so it's again. I'm just gonna kind of throw in a bunch of numbers, like I did last time. And we should be good here. And this is 64 by 64, I think. That's what we care about. That's the button size, which would be the particle size in this case. And subsprite would be I think it's also the same. It looks by the looks of things. And now we can rebuild this up. Like this. Now obviously we want to use the right texture map. Alright. Let's duplicate this 3 times. So we have at least 3 billboards to look at. And I am obviously going to do a 0, 0. I think it starts with 1, yeah. 2 and then 1. And throw that in here and throw this in here so we've got different values so they don't overlap. And hopefully when we load the buffers we have 3 imposters. Oh, sorry, billboards. That all do this thing, which I care about. Okay, so we've got the translation, we've got the rotations camera, we've got the model, whatever. So as far as I can tell, all the particles will be immediate. Oh, and the thing I need to turn off now is the player camera. So, yeah, so the first thing I need to do is go to this, that's the light, so we don't end up in complete darkness. Next is... Actually, the light doesn't affect anything. The only thing we need to care about, actually, is this. Yeah, because the thing is going to be lit up completely. Alright. And as far as I can tell, we should be relatively... Yeah, what I might do is actually change this to 180. Just kind of double it, just so I can see it. Yeah, the spreadsheet size is definitely 64 by 64. Offset is that. Okay, cool. And now we need to render this. So, so this is the 2D render. It needs to go at the end. Okay, it is. Okay, cool. And that's just going to do this, and hopefully it'll hit that, and then do updating properly. Okay. So, have I broken anything in the menu? That'll tell us if I've broken the... Okay. No such thing as flag in the struct. Okay, cool. So scene 2D. Oh, yes. Of course, that will never work. That should now build. One identified in line 68. Ah, right, of course. Let's dereference it first. Then we can use it. Alright. Let's see how this goes. Alright, so we haven't messed up any of the regular UI, which is still using the same shader. And we have a... I've uploaded my particle test squares for you to check out. Oh, thank you. I'll give that a go. Okay, so we got this error again, which I've seen before. It's currently in use, the depth texture. I don't know why this happens. I'm going to do something I shouldn't do. Because I just want to see if... Have I got anything working at all? So I'm just going to ignore the validation error. I know it's bad, obviously, to do that. Okay, so we just get a access violation, obviously. Right. So, look at this. I think I was talking about this when what you should learn in C++. You see this? Like OX C000005 access violation, blah 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 blah. Like you should know these things when you're trying to learn this stuff as well when you're learning to code. Because now I know what's going on based on this, right? Obviously, what's actually happening is that I decided to ignore this, and it's causing all sorts of issues. So, oops. Okay, so we can't, so we got to sort that out. Okay, so begin rendering transition. Oh, am I triggering this twice? I shouldn't be. Yeah, what? Hang on, let's just run this again. I'll enable the... No, I'm just going to let it crash, hang on, in the same way, because the breakpoint takes us out of the place. Oh, okay, that's already your code, that. Yeah, don't worry, we'll crack it. So, call stack. What are we on at the moment? Hang on. If I go to my GPU, we should be able to see what frame we're on. With... is this alphabetical? No. Let's start from the bottom. That was just the order of things initialized? I don't know. So we're on 0, with something count 3, it's fine, okay. I don't know if we've rendered anything, you see, I'm kind of curious. Texture image 0. Depth texture, sorry. Current frame, I think. That's what I wanted to see. Current frame. Absolute frame is at this. Interesting. Have we rendered anything? Oh, I see. That's why the absolute frame is at 1000 something something something. Okay, curious. Let's see if I remove the menu, like, does this get affected? Let's see. Because you might have to pause the device or something. Right. So yeah, it's something to do with the menu. Right, do we have a billboard there is the question. Anywhere. I don't see it. Oh, by the way, what are you even making? Oh, a little space game. I haven't seen that, but that's an error I don't see very often. Okay, I think that's because yeah, that's exactly right. Yeah, that's exactly what I'm making. Nothing super glamorous. You won't be blown away by the game, I don't think. But yeah, it's something. Jeez. Okay, let's change this to spaces finally. Yeah, the tabs are spaces. Yes. Okay, good. Okay, so this is the problem with using Vim. I don't know how to set up things so it's not working in spaces. That's fine. Tabs. Right. Cool. I know it was kind of redundant, but I would rather not see ugly misalignments all over the place in my CMake. It's just an accident when I clicked on this, actually. Right, okay, so yes. Let's regenerate, because that's going to cause regeneration. Give it a regeneration. Oh. Oh yes, I love this song is so good. Just vibing to her at the moment. Right, okay. Right, let's continue. One step at a time. So if I throw this up, so I'm not quite sure why we're not getting anything rendered. Let's simplify things down for now, because we're not going to have the 2D renderer anyway. What I'm going to do is go into the shader and just absolutely make sure this is happening all the time, and then we're going to simplify that. Actually, I should comment stuff out, to be honest. If we're going to use it, assuming it works. And then we're going to have to like make sure the device / queues are finished before we move on to the next object when we're initializing things. Alright, so we shouldn't get any weirdness from that. Nope. Okay. My first thing I want to work out is, one, where are they? And two, so we do need this, which is instant rendered. Yeah, because it's going to be a different instance anyway, so we definitely have them here. So what I'm going to do is just kind of put them at like different places, like 0, 0, 0. I'm going to put 1 at 0, 0, 0. That's the first thing I'm going to try. So we should see it one somewhere. It's possible we got like nothing rendered. Yeah, no, so it should be like where everything's flying around here. Yeah, we're not deleting stuff from memory, that's why that's happening. Okay, so when a load buffers, I'm creating this quad position. And the only real difference is I have camera rotation added. Oh, wait. Hang on, I don't think this is going to work. Now, if I put... let's duplicate this and comment this one out. In fact, let's get rid of this completely. Oh, interesting. Send this off just in case. Might be able to check it's not inside a rock. Nope. Okay. Excuse me. Oh man, I've definitely hit the wall today. I've eaten too much food. I hate it this time of day when it's like super. I get super sluggish. Okay, so transformation by. So when I add, if I just do add quad, I believe, as far as I can tell, I should be able to render something. But it might be the camera data. Yeah, so when I update, which is the standard update, so I assume this is happening. Yeah, okay, so this should be doing a very straightforward get the camera rotation, all that kind of stuff. So the reason that's not going to work is because I'm not updating the rotation every single frame. Which means we're going to have to update the buffers based on rotation. And to do that, we're going to have to... I don't want to do that. Yeah, I'm going to have to update the transform, I think. Which is kind of expensive, but... yeah, alright. Yeah, there's not much I can do about it. So the first thing I need to do is... rob some code from my game. So this... so what we're going to do is just steal... let's put them in a... take that. These are dynamic anyway by default, so it's not like I have to change anything. That. Take this. Go to my 2D renderer. Cool. Next. Oh, hang on. I'm going to make two. Yep, I'm going to make two. Two buffers. Do we have the GPU in here? Yep, okay, we do. Cool. Let's make two of these guys. Because it's a CPU GPU buffer, so they have to be... cool. And now we've got two. We need to initialize them twice. For those who don't know why you have to make two, it's because when you're updating the buffer on the CPU, which I'm going to do, it can't be messing around with what the GPU is trying to read. So we need to be one frame ahead. Mess around with the buffer that's going to be pushed to the GPU, one frame ahead. while the GPU is reading from the previous buffer and displaying that result. So yeah, we need 2 of these now. And you can't get around it. You absolutely cannot. Well, you can. I mean, NVIDIA cards are quite good at handling it, but it's not... I don't know if it's undefined behavior, but it's not good, whatever you're doing. Updating a buffer while it's being read by the GPU. I don't know what that means. I would guess it's undefined behavior. So, when we want to write to this fella... what we got to here? We need to make sure that we're writing to the correct one by accessing that buffer. And then positional, yeah. Sorry, transform. And then based on that, then we can actually write to it. So the current frame counts what frame we're onto based on our frames on flight. Frames in flight. And that allows us to... What is this called? Say buffer, right? Alright, cool. Don't need this, I don't think. So this. Now we need to be able to write to our positional buffer with our new transform. Which effectively is just taking the old transform and then... So actually not going to not update this position at runtime. We're not going to do anything. We're just going to update its rotation. So if I take the position, this thing, what was it created with? Hang on, I've got to be careful here. It was created with this. And... Okay, so, whoops. This is expensive. This is a whole linear update, but whatever. So we need to update all the buffers. So all the positions. Based on that, and then we can take this. We have to use the original data, otherwise this doesn't work at all. Then we can basically we can reconstruct the position. We can update the transform to something else. Pending values here. So, scale and transform are not going to change. So what I'm going to do is just kind of use an identity matrix for them. So if I take the ideas here. So everything's going to just be updated with identity matrix for now because I can't quite figure out how to get the position and scale here without making everything weird. So... we'll just comment these out, and then we'll set them to GLM's identity, right? C GLM's mat4 and same for hue, and that should get everything working. Then transform equals this. Now we can take the original data, which just needs a pointer to whatever we're uploading. And yeah, let me take the transfer buffer access that we did. So that should now be updating. Oh, we need to make sure this is correct. That'll just cause all sorts of issues. We don't want to do any offsetting. Just updating everything. Oh, that's expensive. Especially if we have... it's not expensive right now. But if we have like 10,000, 100,000, I don't know how long this is going to take to finish. Oh. Yes. Yeah, what are we doing with his? Oh, that's what. So what I'm going to do is take this out. And hopefully guys can hear me. So what I'm going to do is put this here. Actually, I need to do this every single time, no matter what, I think. Because we need the, I think. Yeah, we do. Okay, so we need that every single time anyway, so that's going to be convenient-ish. Okay. Done that. Done that. Put that there. And yeah, we need to just pair frames in flights. I tried to avoid this when I was setting this up initially, but yeah, if we're updating things dynamically, there's nothing we can do. Frames in flight. Okay, we did that. Now we can access these pair index. Might be worth, I don't know. I don't know if it's worth doing 0, 1 here, but yep, now we're updating things based on the camera's rotation and the translation. Obviously everything's just going to be in one place because we have zeroed out the position and scale. So you have no idea where that would be actually. I think I need to set the position. What I'm going to do as well is just disable everything else in the scene. Actually, it won't be much a 3D. Right, let's set this position up to be a scale and a position that's always the same. I think it's going to be easier to see. So 0.f, 0.f, and then maybe 10.f. And then the scale is going to be, let's say, 500.f, just so I can see something. I don't care how crap it looks. Right, so we scale it up in that direction. So yeah, I might disable everything that we can see apart from the 2D renderer to see if it's even popping up. If not, we'll throw this into render doc. Because at the moment I can't see anything. So lazy test, very lazy. And then render doc will happen after this, I think. So I'm just going to throw out everything. I don't know if it's being rendered behind or in front, you see. Render doc will tell us this, but this will be quite faster than getting into render doc. But apart from that, yes, we're going to have to use render doc, I think. Nope. Okay. We could have junk data, you see, so... Right, let's get this into render doc. So if you don't know what this is, if people are watching who are new to graphics, this is like a graphics debugging tool. So when you can't get something rendering on the screen, this is a fantastic tool that's to help you do that. So to do that, though, you've got to turn on, if you have validation layers baked into your application, you've got to turn them off. Otherwise, it won't work. Oh, yeah, it's in release. And now I've got to move over the shaders and the textures into the release folder. Cool. It's like a meme, that, wasn't it? Oh yeah, so this takes a minute. And we'll see how we do. I don't know. Visual Studio sometimes decides not to print any output, so it should compile. I don't think there's any issues. So yeah, just waiting for that to finish. This bar down here is what I'm looking at. So yeah. Cool. Are we done? No, we're still not done. Let's check. Can check a few people's restoration is only. Wow. Dimitri, that looks fantastic. If that was all, if that's a billboard, it's a really cool technique. Just looking at your message you sent me. Yeah. So once this is done, we'll be able to see. Don't know what it's going to be stuck on. Nothing interesting, I assume. Why is this guy forked this? Cool. Right. I don't really care about the crashing on close. Let's go into this application. Oh, I need to see it run natively in the file. Cool. Right. Let's move back. And we'll capture a frame. Okay, so what do we have here? We have... Yeah, this is what I'm interested in. And what are our buffers here? So vertex shader. So we should have a view projection matrix. And an orthographical of, yeah, 111, I guess. That's fine. Seems reasonable. Now, if I look at a different one, what are your scene position stuff? What? Okay. So it's not the same at all. Oh, I'm an idiot. I just realized what I've done wrong. If I want a 3D camera, I've got to initialize it in 3D. I've initialized it in 2D because it's a 2D renderer. Yeah, look, there it is, look. So, yeah, that makes sense why they're different. And that's why you use RenderDoc, guys, to debug things, because this is like a super type is equal to UI 2D. And else hinted perspective. Now obviously this is all not the same. So foreign airplane, FOV. I'm just going to take the games version. Throw this in here. Cool. So it should be initializing this. Straight off rip. Let's see. Oh yeah, I forgot breakpoints don't work. What is happening? Let's say, oops, 1,000, and I think I had this originally set to this. But we'll see, otherwise I don't know. Okay, there we go. Okay. How have we got that now happening? You get instability on the skybox. That means you've got instability everywhere. I don't know if you see it down there. The skybox is splitting. The seams in the skybox are showing. That's why I set the background to white, so I can see this kind of issue. So whatever I'm trying to do here is causing issues. Nothing. I don't think there's anything here, but I'll throw it in RenderDoc anyway. What I might do is pass in the view projection matrices into this function anyway and just see if that's a better way of doing it. Just because it's a bit tricky right now to figure out what it wants. Okay, so let's turn this off actually. And capture frame. Go down here, see the buffers, the pipeline shaders, this, and let's just check this as well because I don't know which buffers. Like, oh dear. Well, that's a big giveaway of what's wrong. Well, there we go. As you can see, we have massive values that are all junk. Yes, so the position of these things are just not even going to work at all. And I don't know why. But we'll dig into it. Okay, so the question is, when I remove this, do we still have the same issue? I figured out how to design my notes. Well done. Fantastic. I hope your designing of notes works out for you. We have an error, which was, oh, of course, Yes, you can't link with that running. Weird. Why is this happening? This is the thing I don't understand. So what I'm going to do is, we're not going to have a 2D camera per se. We're going to update it. We're not going to do anything. What we're going to do is pass in the values. So let's go to our header. Const mat falls. View. And then project. I'm going to pass these in from the main camera. And hopefully that should fix some of the problems. Your notes have gotten big. Yeah, it's helpful to have small notes, in my opinion. I am lost in my notes, lol. Yeah, split them up into little bits. Yeah, well, you can do what you want, obviously, but that's what I would recommend. So we're going to do this. And then we're going to do this. Guys, I think it's going to be one problem solved. We're going to use the same view projection matrix. And also the positional matrix now needs to be fixed. So if I scroll down to here, we have cool. Done that. Then what we want to do is okay. Let's build this and see how. Let's just run it first. For each type of information, I will put in a related subfolder. Yeah, go for it. That's a good way of doing it. Quadro. Right. Okay. So hopefully I can just cheese this. I'm not going to use that for a minute. Interesting. Okay. So next is to figure out why that's happening. And this is definitely a render doc situation. First, I want to also figure out that as well, because that's a big issue. Oh, we actually don't know if these values are invalid yet. Right, okay, so yes, render doc it is. Launch application. Yeah, why are we getting a black window? I don't understand this at all. Texture viewer. So nothing's rendering. Oh, there they are. What are these for? And then it just renders on top. Okay. Oops, no, that's not what I wanted. Check this is good. Yeah, that seems reasonable. Next is this, which I assume is all junk again. Oh no, it's good. Hmm. Trying to think. Right, so we have things at different positions. Quad size. Why are they 128? Oh, that would be the... Okay, so the color is 11111. Fair enough. The text codes, which wouldn't have anything to do with anything. The position is 00000, as far as I can tell. Let's change the song. Let's pick... Yeah, there we go. You do not hear any song. You should now. How's that? Can you hear that? Do 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 do. I can turn it up even more. Good, good, good. Okay. That's good. Right, you should be able to hear me over the song now. Yeah. Yeah, I was playing like a really quiet, sad song, I think. And it also didn't help. This is like one of the best soundtracks. It's nuts how good the song is. Now it's too loud. Okay, okay, okay. Hang on, hang on. Now it's too loud. Turn it down, bro. How about that? Yeah, let me know if that's too loud. Emmanuel. You should be able to hear it when I'm not talking, but it shouldn't be over. I shouldn't be shouting over it. I don't know why we're just getting nothing on the screen because of this render. Hi Raj, how you doing, dude? Right, trying to figure out how to get this working. We need... Yeah, it's perfect. Fantastic. Cool. Yeah, thanks for helping me out with the volume, guys. I can't hear what you can hear. So yeah, I don't want to be... Let's see, let's remember this. Okay, so you like it at 40. Okay, so that was correct the first time when I did this. Perfect. Cool. Let's actually have changed my mind with randomness. Let's go with a... I don't know if it's too distracting to constantly change, but this is the song I was talking about. I don't think you could hear it before. I've become like obsessed with it. I used to play this a lot when I was a kid. Classic Mega Drive music. Why are you blocking out the screen, which I don't understand? Let's set everything to 00 maybe. And the scale to 1:1. Yeah, so I think I'm going to do that because I think that might be disrupting things. Yeah, okay, so position's fine, but I think the scale is too big. Gonna try 1:1 maybe. Let's see. Aha, look at that. We have that makes sense, okay. Unfortunately nothing on it. But yes, we need to update it basically on camera now. Unfortunately, yeah, nothing's on it, which sucks. What did encourage you to start programming and game dev? Two separate things though. It was the skill. It was like only the one of the. I felt like it was the only one of the skills that I could learn. Yeah, let's go through the Mega Man theme tune till I get bored. Once upon a time, a long, in a galaxy far, far away, when I was Mega Man, I tried to learn to code, and no, anyway, enough of that. No, it was what was it? It was just a fascination with the fact that I could learn something myself. So that's why I started coding, because it was like fun and I could teach myself literally everything. I could get a job effectively by teaching myself completely. I got into game dev because some guy who was older than me I thought was like the coolest guy ever. I was like 16 and he was 19. I barely learned how to code anything at all, and he was getting ready to go to university as a game artist. And he wanted me to code things for him to make games, but he didn't know how bad I was, and I didn't know anything about anything. So I was like, yeah, sure. And that eventually led to me trying to do what he's doing. Yeah, and try this playlist, but copyright issues. I will actually, Raj. Yes, unfortunately, probably will. Why aren't you going to the next one? Go to the next one. There we go. Like, please go. Might have to refresh the thing. Right, so now we need to be able to refresh. Sorry, and now we need to be able to... So it is correct. It is there. Let's just update the color, I think. I'm just going to do color now, because for some reason the texturing isn't working. I don't know why everything's like so broken today. So we are going to do the billboard with just no textures. And the color is going to be... There we go. Okay, it's actually doing it now. Yeah, I'll grab that playlist off you there, Raj. Let's see. We'll paste it in the other window. It's on my other computer right now. I see. Yes, this looks cool. Yeah. I don't think that would be copyright claimed unless it's from movies. All right. Yeah, we might listen to it after, maybe. I think that's gonna be fine. I don't know what it is about older video games. They just got music right. Like, sometimes they just absolutely hit it out the park. This makes me want to play the game, you know what I mean? Listening to this music. Whereas, like, in modern games, it's, like, so atmospheric and in the background. Which, obviously... I like gaminess in video games, you know what I mean? You know, I like the fact that the video game is 100% a video game. I don't want it to be like a cinematic experience where sometimes I press a button. I want it to be like a proper video game. Like, I want a bird trying to drop eggs on me, and if I dodge the egg, then tiny little robot birds try and attack me, right? You know, like something random like that, right? Now you replayed the Streets of Rage series. Hell yeah, man. I love that series. It's peak. Peak 16-bit. Right. Let's see if I can update the... So, yes, we don't want a scale matrix of that. Definitely not. We want 1, 1, 1. Position 1, 1, 1. And what I'm going to do is there a color here that I can set to? Do you know Tokyo Spliff? Yes, I do. Cool dude. Partly inspired me to stream, actually. I thought, you know what? If he can do it, I can do it. Why not? Just give it a shot. So, yeah. Do I have colour in here? I don't think I do. So what I'm going to do is, in the 2D renderer, I am just going to hack in some colour. Yeah, V-color. How's this working? Oh, it becomes part of the vertices. Okay, that's how it is. Let's see if I go back to the 2D renderer. When I heard the boss music, I started playing them. Yo, yeah, it's super sick. Did you hear it from my streams by any chance? Because I have played the boss themes a few times. Right, so 11111 should be white. I don't know why it's black. Lots of people, I don't know. Lots of people do not know his name. Oh, Tokyo Spliff? Right, yeah. Yeah, he's like the GOAT right now of YouTube people making programming music. You had no idea about Graphics Pro until you watched his stream. Yeah, makes sense, yeah. Oh, is that Tokyo Spliff's real name, Chris? I was gonna say his name's Mr. Tokyo, but I guess not. Please, Mr. Tokyo is my dad name. Call me Spliff. Anyway, yeah, so stupid. Right, okay, so let's mess around with billboards. Let's see if we can. Yeah, I guess so. I actually don't know much about Tokyo Spliff, to be honest. Outside of his streams, but I guess it must be, yeah. You know, because I think a lot of people who watch my stream watch him as well. I know I watch him when he's on. We'll have to spot each other in chat if we see each other. Tasmanian goat has 3 goats. Yeah, that's true. Yeah, because yeah, the joke there is that Tokyo Spliff has, if you don't know. So who are we talking about, guys? Just for the people who are like, what are they talking about? There's a graphics programmer on YouTube who streams sometimes. He's got further along with his engine than I have. Ooh, no, I don't need that. And he's called Tokyo Spliff on YouTube. He lives in Tasmania, Australia. And he owns 2 goats. So we say he's got 3 goats, right? Him and the 2 goats he owns. He like lives in the middle of nowhere. I don't know anything about Tasmania, so yeah. Okay, so as far as I'm aware, this completely breaks everything. Yeah, okay, so that... Whoa, okay, interesting. Why is it so big? Oh, okay, because we've got junk, I think. Hang on, if we go out to the infinity. Yeah, it's become junk for some weird reason. And it's still not rotating. After all that. Yeah, we need to... Yeah. Oh, does he have coffee and energy drinks? Oh, no, that'll kill me. Honestly, you don't want to see me on too much caffeine. I'm highly irritating. Okay, very weird. Yeah, maybe one day we'll play I'll do an 11-hour stream, right? And he boasts himself. Oh, he boosts himself with them. Yeah, makes sense. What we might do one day is do an 11-hour stream in honor of the goat. He drinks them at the same time, bruh. Oh my god, maybe not. I can't honor the guy like that. Not that he's dead or anything. So just do a parody stream. I'll have to like pretend to put energy drinks in a cup or something, so I can drink water. Put a wig on. finally do the face cam. Only after 6 hours. Yeah, that makes sense. Damn, you've watched him more than I have. I mean, he's obviously a cool dude. Why is this getting corrupted completely? Update this. This transformation matrix, current frame. Oh, yeah, okay, so let's do an identity matrix here, I think. Map 4. Yeah, I feel like I actually might need an energy drinks today. I think I am struggling. I'm on the struggle bus today. I don't know why. I just hit the wall after I've eaten. Right, so I'll do that and just see how that makes things look. I think what I might do is just like not use. Yeah, I think it goes too small now, doesn't it? Yeah. Yeah, I think what I'm gonna do is I'm just gonna set the color to hard code it. So this is just gonna be vec 4. So I'm just gonna do 1, 0, 1, 0, 1. Don't do energy drinks, yeah. Yeah. Yeah, I'm really bad at handling caffeine. So yeah, ooh. Okay, that's a big giveaway. What the hell is going on here? Why is it doing this? Okay, so it's not 0 width. What is happening? It's causing lots of instability as well. Oh, okay. What? Okay. Oh, this is tough. I've got this right around, right? View projects. Project view. Project view. Alright, I'm just going to do the insane thing, because this feels like almost like I've got a matrix multiplication mixed up. No, it's just disappeared off the face of the Earth now. Or the face of the planet. Face of the space, I don't know. Considering we're in space, it's kind of a... I just noticed the light in here is kind of strange. The directional light. Why is it getting brighter on one side? It doesn't look too bad, but... By the way, I'm moving way faster because I'm in release. So let's put this here. And let's... Okay, so let's... For now... Yeah, I like to think with Toko Spliff, he's a sprinter and I'm a marathon runner. I can just keep going and going. I'm more persistent than I am. I can't do like 11 hours all at once. But I could at least do a couple of hours every day. I don't know if he's still doing that. He's probably doing that himself, but Alright, so this, what does that do? That player deleted a rock. Ba, 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 ba. Oh, shit. Yeah, okay, so if you're going slow, you'll be able to see that. I think I need to increase the intensity of this spotlight. It's a bit too dull. Increase the lumens. Let's see, I'm just going to get a bit distracted and do that real quick, because I'm kind of curious. I've been thinking about that for a while, like, how much of increasing the intensity? It's already, like, super high, but... double it. Double intensity. Oops. Oh, get out of the way, you deleting stuff. Yeah, because if I... There's the purple rectangle of doom. Yeah, we've got the hantavirus coming back in. It is gross looking, I do apologise. Yeah, I've definitely introduced instability into the engine by doing this. I think what I'm going to do is just increase the inverse square by a bit instead. Rather than getting close to the floating point max. Yeah, that's better. Yeah, it just needs to be further out. I prefer it to be even more further out, to be honest. It's funny, what I could do actually is just have an infinite light, but I don't think that works very well. So I'm gonna let's do 5,000. Just need to get it further out, because my scene is huge, by the way. That's... Whoa, okay. What are you doing? What? Very strange. Okay, I'm glad I reran this a couple of times, actually. So it's telling me that the data, no matter what, is unstable, so I've got to be careful for thinking that this is correct. Anyway. And you can see it's like making things very unstable. We're going to end up with a synchronization bug in a minute if I don't sort this out. So I get a hard crash due to a synchronization bug. Okay, so let me just think for a minute. So for some reason we can't upload data to the GPU because it's, I don't know. Let's just check everything's like what I want to check first is so we've got view project, that's fine. We've got frag there, which is fine. Yes. What is going wrong here when we set up the buffer? We have textures. I think this might be going wrong because we're loading. We're not loading any textures here. I think that's part of the problem. If I go to the fragment shader, hang on. get rid of this. Yeah, I think we're not loading textures in our game. And if we are, we're loading the wrong one. So if I go back to game, hang on. Yeah, where's our load textures? There's nowhere. Okay, so load textures, that's a big problem. I need to have like an error texture so I know that I haven't done this. But alas, that is more work. Alright, so we should hopefully see something. Oh, the problem is it's going to be hard to see now because we've got that instability. Alright, yeah, no, what I need to do to check if this works. So we get the instability and we're trying to upload the shaders every single frame. So the next step to do is if I go into not 2D renderer, no, yeah, it is 2D renderer, and remove this updating. It's my favorite track from Mega Man 2. So I said it again, outside of Wily's Castle 2, at 1 even. Right, has it gone inside the rock? That might have just... No. Let's run that again. I swear it should be here somewhere. Should make it massive, maybe. Where's it gone? We're not updating it anymore, which it should be around. I don't know why it's not appearing. Okay, let's go. Y maybe? Yep. So if I do this again, we get nothing. What? What is happening? I swear this worked prior. Okay, so it's not working at all. So if I go back to the game again. So we have billboards. We have 3. Let's just do 1. And we have a load textures, which loads the texture in. Load buffers, so it loads this thing. Quad position based on this data that we've passed in. We should have been added, yes. We got an instance index of 1. So when we actually run this stuff, it's there. Let's just check our vertex shader because I've messed around with that a bit. Project view, no, that seems correct to me. Transform. Okay, so what I'm going to do with the transform is just maybe make the simplest transform of all time. So that is going to require me to be clever with the coordinates. Yeah, let's go into make billboard, right? And I'm just going to type in, I'm not going to ignore the arguments for a minute. Super simple, but I want to make sure that nothing weird is happening. So we should have a matrix that we can actually use here. And I'm also going to get rid of the camera rotation because I don't know what that is at this point. So I'm going to duplicate this. I'm just going to comment this out so I don't lose the data. Okay, cool. Fun fact, I've only ever beaten this once on normal. Not a true gamer indeed. Rubbish. Yeah, it's kind of like, yeah, where the hell is it? Yeah, even on normal it's very difficult in my opinion. Let's throw this in render dock again. So we should be able to see it if I move back. So I'm just going to move back a bit and then capture frame. Right, so it's weird, isn't it? Because it's like 2D rendering is so much easier than doing a billboard for some reason. Okay, so based on that current frame, I assume that looks normal-ish. I'll have to check everything out. So transform is just a that. So we do have text chords here, which is good. So the transform is one. Yeah, it's just an identity matrix. I mean, I could obviously scale it, but I don't think that's going to do anything. Let's scale it by 3, so it should be like super obvious. And let's see. Oh, we can't obviously do that. I don't see any like bad data anywhere, to be honest. Nope. This is so unstable, it's ridiculous. Another stretch. Get some water. Okay, this is the sickest track in the whole game. What are we doing? Well, we have... So we have 2 frames. Maybe I'm going to go back to 1 because we're not updating it and just see how this has been affected, because I don't quite understand why all of a sudden is this like completely breaking down. It almost feels like because of 2 frames in flight. Yeah, so there we go. Okay, so it's like that caused the issue, you know? I don't understand why. No, it didn't. Okay. I do not understand what's going on. Trying to think. Just thinking right now. Let me just look something up real quick and see if that's gonna help. That's just on my other computer. All right. No, I'm just trying to think of something to do to try and solve this problem. So, we've got a buffer here, right? I don't know. I don't know what's going on. Like, why was it working before? I have no clue. Because we've got a view projection matrix, we've got the instance index. I'll just turn off everything again in the main loop and just see if that helps. Just see what we see, right? Other people would say AI. Yeah, I'm sure they would. Especially the people selling it to me. Nah. Yeah, I'm just gonna make sure that we've got no like weird bug here. I'm sorry to breathe the same air as you. Oh, I'm really not that good. I assume that's why you said that. Right, so, right, so if we go to our let's just see if we got some weird bug happening. I really am stumped. Why it sometimes works and sometimes doesn't. So yeah, I'll just rebuild this for a minute. Neither do I don't understand. It is what it is, isn't it? Oh, crack it. Because it says all on render docs. It says everything... No, we haven't got a weird bug. Okay, I was wondering if we did. I can't even code without... I can't even do a addition without Claude. Fair enough. It just takes practice. That's the only reason I'm potentially better than you. But I don't use AI, so it does help me, you know. I am able to. Let's see. Because I learned before AI, I don't feel the need to use it. Yeah, where is this? I was just checking out the flashlight effect. Obviously, you wouldn't get this close to an asteroid without crashing into it, but yeah, it's decent. It's better now anyway. Still a little. I think what I can make it better is just make it harsher. We crack our brains. Yes, we crack them open, put the knowledge in. What I'm going to do is just a bit of distraction. Hopefully that's okay. But I'm going to change the inner and outer angles of my function to outer. I'm going to make this larger. Maybe 4. And this a 6. I'm just going to mess around with these angles for a minute. On and off for years. I really took it seriously in 2017. Thank you, Doug, for deleting that. So yeah, quite a while. Okay, that did the opposite of what I want. So smaller angles. Oh, that makes sense, yes. Okay, so let's go to a really small angle. Let's go a crazy tight angle. Hello, Mabdo. How you doing, dude? Just checking my... I really shouldn't be messing around with this, but I want to see how to improve the tightness of my... I mean, what I could do, which is obviously bad, but... that. Don't do this. Do you like it, guys? This is a flashlight slash torch. Bit bright, right? But I'm gonna try and yeah, let's put that back. I'm kind of curious though. I'm just going to mess around with some values here when it comes to lighting. I'm fine, thank you. I'm pretty exhausted trying to make my tools develop and work. I see. Well, I hope you get rest. Hope you do well. Yeah. Where's Mika? He's usually not around till 4, I think. Okay, so the intensity is way too low here. So I'm just gonna play around with values. I'm just kind of curious if this is a good idea. Mega Man. Right. Yeah, I do like this attenuation, but the problem is it's infinite. I don't know if this is better. Like an infinite length of light for gameplay reasons. I don't know. I'll come back to that. Okay. Yeah, because I get it, you know, increases to 300. But if I put the square fall off radius in, which is the distance of light that gets worse, sorry, gets less light as things get closer, we see basically nothing when the intensity is this low. You can see it doesn't light up this until we get like basically right close. So I wonder if I do the inverse of the intensity and then I just increase the intensity really high, like it was. I wonder if that helps, like the attenuation versus the square fall off. Would you stop deleting things, duck? Okay, so what I'm going to do is just increase it one more time by an order of magnitude. I think that's where it was last time. See, it's a bit too dark. I mean, obviously it's getting brighter because the... Yeah, I think that's decent. Yeah, just a square. Obviously you can see everything fine this direction. The only downside is the directional, like it's intense. Oh yeah, and I also put Mega Man 3 tune in. It's my favorite Mega Man 3 tune. I haven't put any others in though. Shockman. Okay, I wonder if I can make this smaller and see what that does. Sorry, I'm messing around with a lot of different things right now, but I kind of want to see... No, it just makes it harder to see. Now, curious, if I put in 0... We're just going to get not a number and weird artifacts. Strange. Yeah, I'm just going to try different things out because I want to fix this. It's kind of like been bothering me for ages. Excuse me, Doc. You're supposed to be colliding with things. Oh no, I've turned it off. I remember turning it off actually. Nope. Right, we need light to position, otherwise that'll never work. Light direction, it's just negative I, inner angle. Ah, okay, there we go. That's the attenuation fall off of a pure spotlight, but we at least can see like how it works, the spotlight. Obviously this doesn't look very good, but it's kind of trippy. Like I just need it to be like the range to be larger. Yeah, I don't know. I don't know what's wrong. I feel like something's wrong and I can't figure out exactly what it is. I need like less attenuation, not more. Okay, so we're definitely on not Mega Man anymore, but this song's good. Okay, so enough messing around with the... Right, so I'll put that back because I think it's just breaking the things. I wonder if they're the same. Sorry, I'm playing around with so many things here. But this has been bothering me for a bit. So if they're the same, I assume it's the same. Okay, interesting. We don't have... It's like a spotlight. Point light even. Yeah. Ah, okay, so that's just a point light. So divided by 2. Or like minus, I guess. So 3.5, so like 0.5 or something. Let's unplug this for a minute. Don't want the laptop overheating. That's why I can see your chats. So if the attenuation fall off is too small, then we don't get any effect at all. Lighting direction, angle, light direction. Okay, so yes, that's all fine. And again, we just get like a what I'm going to call a perfect. Hang on, intensity. Now I know it seems dumb, but if I just return back light intensity, I assume everything's lit up to a like blinding white. Yeah. And that's because the intensity is like so high that we only get like doesn't even matter what we look at here. Supernova light, yeah. just about to we are the exploding sun. Okay, so let's get the radius back and mess around with the radius. Now, when I did this, this just made it like not work at all. In fact, let's put the light intensity in there. We should see basically the light not work at all until we get like so close that we're basically going through the geometry as we go slow as possible. Oh yeah, that's true. Yep. It is. This is actually, who is this by? It's the Watch Dogs soundtrack. I hope it isn't copyright strike, but who made this? Yeah, this is just hidden in a file that it was never released. But yeah, whatever. If it's copyright strike, that is what it is. Yeah, this guy like reverse engineered all the music out. It shouldn't be, because it is a video game. So how are you supposed to stream a video game if it's all the music's copyright striked? Yeah, it's my favorite track in the whole game. They have some other good tracks. Most of them are action though, but this is like, it's really fitting for the scene because you're figuring out like the outer angle needs to be bigger. Sorry, the scene, because you're like, you're figuring out where this big central computer thing is. As the sun sets, it's really nice. Yeah, this is the second best track, I think. Yeah, we're really not getting anything when we do that, so... I don't know how this works at all. It's like I need like extreme values to get anything working. Like that is just, I think, too big for a float. Nope, okay, guess not. Yeah, the intensity's too low here. Way too low. Yeah, I'm one of these guys who just like drives around in this game just for fun. Oh, is Risk of Rain music like this? I'll have to check it out. Okay, so now we're not getting anything at all. So I'm just gonna like Control Z my way back to something that makes sense. Okay, so inner angle. Yeah, it doesn't really matter what I do here. If I put them at the same, or make them like basically the same, I don't know what 7 would do. Something's not quite right. These numbers are insane. Yeah. I know. That's what I'm trying to think. Like, why are they insane? Okay, so the player is still doing stuff. It's just like it needs to be so big for some reason. I feel like my scene is just huge, you know what I mean? You know what I might do, actually? You know what I might do? Hang on. I think I have something called global scale. If I take the global scale, multiply it by... Yeah. Okay, so what I'm going to do... yeah, give me a minute. I think I know what's wrong. Hopefully we have global scale still. That'd be really annoying if it wasn't here. Global model, okay. Whatever. That'll do. Okay, cool. Global model. Okay, got model scale, which is... Okay. Originally, when I did this, it was like, it was a lot smaller. So if I make this everything smaller... hope it's all going well. Yes. Oh, yeah, it's going good. Apart from the fact that I've just made everything tiny. Like, beyond belief. You see what I mean? Like, if I just make everything smaller... The downside is the non-collision detection will work now. Working with STL and GPU recently, part of the goal to keep things cross-platform, so no binary or buffer device address for me. STL GPU is a bit more restrictive, I see. Alright, so obviously it's too small. It's like 0.1, so it's 10 times smaller. I think my scene is just huge, huge, huge. See what I mean? Like, now if I turn off this, this is like more realistic. Like, this is what I wanted. But because my scene is so, so, so huge, we're getting like extreme silly values that don't make any sense. I think that's what's happening. I think we're getting like massive, massive, massive values. And even this now this makes like it's too bright. But at least you can see. You should name your game Escape Point. Yeah, that's fire. That actually, I haven't thought about my name. So let's I'm gonna half the size again. Not half the size yet. Yeah, I'm gonna half the size. I think then I've got to. Okay, for the collision detection to work. Yeah, because I can just slow you down, you know. If I think you're moving too quickly. So let's try the collision detection. Hang on. It basically RHI. All it does the back end of metal VKDX12. Oh, it's cool as hell. Great progress, man. Yeah, thanks. You're still not. You're still not getting light with massive numbers. Now, if I shrink everything down, then numbers don't have to be as big. That's why I'm doing this. You see, originally it was this. It's even smaller, actually. It's like 0.001. So I'm actually going to go with that. And then I can... Originally, that's what the scale value was actually at. So we'll see how big this is relative to my camera movement. So I might have to slow this down a bit. Yeah, okay. So this is like too small, I think. I don't like this too... It's too much. Actually, the intensity is way too high as well. But this might be accurate, right? At an intensity of, what, 5 billion or whatever I'm doing? Where is it? If I go to my... Yeah, I'm super happy that you're... Super happy. I've been watching your progress. I obviously couldn't reply because I was live streaming, but hell yeah, brother. I'm super happy with what you're doing. Yeah, I've heard game. Yeah, box. Yeah, I've been told multiple times in the stream. It's awesome. Okay, so look behind us. That's relatively okay. Yeah, so obviously the intensity is way too high. And it does feel like there's not enough rocks now because they're so small. But if we have an intensity of like what, 5 million, like 1 million, I don't even remember. Am I going to make the models myself? Probably not. I haven't really thought about it, honestly. It's one of these things where I'm kind of like, well, when the... Well, that's true. I have thought about it a lot. My plan is basically art comes last. Art will be the last thing I do. Yeah, so... The reason for that is... Okay, that's cool. Yeah, I'm gonna stick with that for now, but I also need to check out collision. It's because I don't want to basically give an artist nothing to do, spend a bunch of money on them, and then, you know, decide that I want to change everything right at the end. I want the game to be basically done, and then I just want to be like, all right, do these small few assets, please, artist. That's my goal anyway. What do you mean? You don't like the duck? Yeah. Right. Okay. So where is our player? Yeah. Now we're moving way too quick. Oh, our player's not being updated with us. Okay, that's fine. So we update the player camera. Where's the player then? Oh yeah, everything's not scaled with this. Yeah, I've got to keep the duck in the game. Yeah, then quit the game. Got to keep the duck in there. It's the only reason anyone wants to play. The duck is the game, exactly. Okay, so if the scale is 1 for everything, if I'm scaling everything down visually, then I need to scale everything down. I need to scale movement down, I need to scale everything down. So, I need basically a global scale that kind of scales literally everything. So if I take the debug geometry, scale it down, the collision detection should work. I know your work is largely been game focused, but would you ever consider making an editor / runtime split? If you like how the engine looks cross-platform, if you like split, if you like how the engine looks and performs once it's close to finished. First question, yes, but I'm only ever going to do stuff for the game engine if it's relevant for the game that I'm working on. If I need a editor, I'll make one. And stuff like that, right? Now I could just like put one in there for no reason. I just make like I am GUI look cool, but like I don't see that as like progress. I feel like that's for my specific use case, that'd be procrastination, just to make things look more cool for people to go, wow, cool, awesome. Yeah. You know, I think it would be more impressive. I think people would be like, wow, your engine looks awesome. Because it has a GUI and stuff. It looks like Unreal and Unity, but it's not something I need at all yet. But if I do need it, it will be added. Because I don't think even Tokyo Spliff has a. I just bring you up again. Biggest fan here, right? I don't think Tokyo Spliff has that. I think he's trying to do the same thing as I am. He's more skilled, obviously. I'm not going to deny that, but he's very on the ball when it comes to implementing the right things. Right. Anyway, so if I scaled everything down, I need to scale the. I think, okay, so we need a couple of things here. We need to update physics, update player camera. Yeah, it's moving now way too quick. So if I just scale this whole thing down. His engine is 8+ years old. Yeah, good approach, my opinion. Thanks, dude. Yeah, it's I don't want to do what I did last year, basically, and just make like pointless stuff. I mean, it's not pointless, the meshlet stuff, but still. Yeah, his engine's 8 years old. Yeah, I don't know. Global scale just helps with debugging, honestly. I could just say to the artist everything needs to be small, but where's the camera movement, target movement? Is that using twice? Yes, no. That's rotation speed, yeah, that's fine. Delta time, I think I just need to multiply this by 0. Obviously this is just going to be global eventually. 0.5 f Yeah, engine of Theseus, yes, exactly. No, it's still really quick. Oh, is this the wrong camera? Hang on. Yeah, I don't think this is the right camera. Yes, that would make sense. So, times by 0.05. F. So that should at least turn down the rotation. Yeah, zoomies indeed. It's to slow us down. Yeah, okay, so the rotation's good. Now we just need to do the... Oh no, I forgot about this side effect. Ah! No, we can't do that. That's very annoying. I've got to be very careful here. Subtract, direction. Okay, what is this? Why is it -10? That doesn't make any sense to me. I think it's a bit slower, maybe? What are you confused about? Sorry. TIS coding is... I'm going to watch that video. Nice. Yeah, go ahead. I feel Ziggish way. I really like the allocation strategy of the Void engine, to be honest. Yeah, I'm very data-oriented design, and they're data-oriented design as well. What's the problem I'm trying to solve here? The whole scene is too big. That's the problem I'm trying to solve. Everything's massive. Everything's massively sized. So when we move a unit distance of like 1, it's so small. It doesn't make any difference. I just also have to do is speed up the player and speed up everything. But it makes a difference until we hit lighting, right? Lighting's messed up by this because it has to travel a certain distance to hit the camera. If the camera's like miles and miles away because everything's massive, and I'm just moving really fast, then the light doesn't hit the camera until ages, until we get really close to the thing. So we need to make everything small again, like kind of like a reasonable distance. Now I could just go into Unity and just make all the assets tiny, but I'm trying to get this in a way that I can just go like, okay, dude, you're just gonna be a lot smaller. But I've built everything around a certain size, so it's kind of like hard to fix. Like straight off the bat. So right now we have the player camera, which always moves in the Y direction. Sorry, it always moves forward. And because of that, we're getting like instant full speed ahead movement. Alright, let's get rid of this. That's not going to work as well. We've got to be also careful with the rotation speed, because if I slow down the rotation speed in the wrong way, I'm slowing down the deceleration of the rotation speed. So what ends up happening, if the rotation deceleration is too slow, then we forever turn in one direction. And we have this like really annoying, like, it feels like you're turning in a tank that like accelerates, and then it's so you have to turn the wheel 1,000 times to stop it turning the other way. You know what I mean? Like it's like driving like a big tank, which obviously we don't want. Yeah, basically dampening. Yeah. So I've got to dampen in the right place. That's what I'm trying to figure out, the dampening. I wrote all this code like such a long time ago. Yeah, select mouse sensitivity, for example. Let's see how that. So it's. I wrote this code like ages ago. Angular, yes, linear and angular dampening, without doubt. That's what we're trying to achieve. Okay, so that's. I can't notice any difference, I don't think. But at least we're not spinning around. But we might not. Are we even using this? No. So I'm going to set this to like this, even smaller. No, I don't think it's doing anything. Where's the player? Let's go to the player. I think I need to investigate what's happening in here. Ah, right. Okay, so that makes sense. The desired velocity is way, way, way too high. Let's change this to 10. You see what I mean? I've sped this up in the game engine because the scene is massive, right? No, it's fine. Let me just see how that's. Okay, now it's way, 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 way too slow. But that's fine because that's going to help us out. Let's say player. Okay, player movements. So let's do 100. Yeah, let me type this out. So think about this. We have attenuation. Do you know what attenuation is, Mabdo? I'll ask you that because you're quite active in chat. Maybe you'll be able to. Okay, so that's better. But the rotation obviously is way too high. Yeah, the rotation's too high, but that's fine. Maybe. So attenuation is... So if you have a light beam, right, going through a vacuum, then there is no energy loss as it travels through a vacuum. Yeah, light attenuation. Now, if it's traveling through like thick fog, then it's going to lose energy really fast, right? It's not going to get very far through the fog. Now, imagine that we have basically a light year apart from a light source and what it's supposed to be lighting. The attenuation, regardless of what it's hitting through, even if it's through a perfect vacuum, is going to be really, really, really low. To the point where it's basically, you can't see anything at all. If it's really, really close, like a really bright light source, and it's, we're really close to the thing, then there's no energy loss, basically. It's like perfect energy transfer almost. So as the objects get further away, the attenuation gets larger. That's what we've calculated anyway. So if the scene is huge, then what ends up happening is the attenuation I have is like, let's just say regular, right? It's like a regular sized attenuation. And I've either got to turn up the intensity. Yes, I have, Raj. I've either got to turn up the intensity massively, or get rid of the attenuation altogether, which you saw when I disabled the attenuation. But then I got an infinite light source that goes on forever, which may or may not be a good idea depending on what you want. So at the moment, I'm like, all right, let's just adjust the size of the scene so it's just like regularly sized. And most of the time when you're working on a model in Blender, right, it's massive because you want to make sure that you get all the contours and everything look nice. But like when it's in a video game, it needs to be like shrank down considerably because you're going to put it in the game and it's going to be like that. Because it's much easier to work on a huge asset than it is to work on a tiny little one in Blender, right? Like zoom right in, trying to work the triangles would be impractical. I'm getting a professor energy from this explanation. Yeah. Woohoo. Our graphics program is just mad scientists. Yeah, it feels like that sometimes. But when you had the spotlight, you basically... but you were basically in the face of the rock. Nothing happened at all. Oh yeah, that's because I turned up the attenuation too high and reduced the intensity too low. However, your directional light works fine. Yeah, directional light is... directional light doesn't have a... So we don't have attenuation for a directional light. Directional light is... all we're doing there is we're just saying the light comes in these parallel vectors are the light source. Bounce that to the camera, please. That's basically all we do. We don't do anything fancy. We don't have attenuation fall off. It may look bad if you're doing something like fog. You might just end up lighting the same surface exactly the same way. Versus something like all the other light sources. But directional light is a technique for... Yeah, directional light is coming from so far away that the rays are parallel. Yeah, that's exactly right. So it's only really meant for outdoor scenes, really. I mean, it's been used for decades, I think, at this point, directional lights. Just because it's so easy to do. But yeah, you kind of limited with what it's supposed to do. In space, it makes sense, right? Because of the because it's supposed to be a sun somewhere, then it's like fair enough. Everything's lit from one direction. That kind of makes sense. That's why I have directional light in. But yes, the spotlight is not working very well. It's a good approximation of sun if it's just, yep. I think it's used for shadows. Right, I haven't touched shadows unfortunately, so I can't quite quote you on that. But maybe you know more about that. I saw you did. I haven't written any shadow shaders. Haven't done any residence cascading or whatever it is you're supposed to do. Some kind of cascading thing in your shaders. Right, so we need to match this player speed effectively. We have a lot of magic numbers here. It's kind of tricky. So rotation is not affected by this linear movement. Weirdly, when everything's scaled to one to one, hang on a minute. Let me think about this for a bit. Okay, let me. Sure, you can explain stuff. Metaprogramming in Clang is much like GCC crashes with internal errors. Oof, that seems awful. Yeah, good luck with that if you're trying to do metaprogramming and that's the error message you're getting. Right, okay, so right, if I increase these things, I'm just going to keep increasing these things and see if we can match our player speed. Or what it should be, right? I don't know if we're getting too fast or too slow. That's too fast. Where's our player? Yeah, so our player is kind of just chilling. Why? I don't understand why the player is not following us here. We're definitely getting in here, right? Now, if I update the position not by hang on. The problem is yeah, I'm just going to open a window real quick. BRB. It's getting very dark. I'll leave you on with my favorite Jack 3 soundtrack. Yeah, let me just... I mean, I'll still be around to yell at you from a distance, but it's getting very hot. Very, very hot. So I just need to pause that timer. Excuse me. Didn't mean to make a noise there. Yeah, be right back. It's better. I was overheating. Oh man. There we go. He couldn't expand the auto parameters in the lambda, said Dimitri. I don't think Mabda is talking about a directional light. Yeah, if you want me to I always read out what Dimitri says, but sometimes I don't miss it. Sometimes I need to say that I'm saying what Dimitri says. Mine doesn't, but probably a bug in... Let's get rid of this. We are back. Yeah, I don't know. It's yesterday we couldn't... Dimitri had to translate his words for us, but it seems to be okay right now. So here's the thing, right? If I scale by... I'm going to bring back the scale to 1 just for a minute, because I want to see how the physics is affected by this. The physics engine is considerably physics... yes, Dimitri says I'm talking about the error I found. So he's talking about like an error he's found, and it looks like horrendous gobbledygook. So I'm gonna put the scale back to 1. Obviously, it's gonna break the light again, but I want to see if what I might try and do is actually scale down the speed and. Okay, so. Yeah, we're going a lot slower, which is fine. But if I do a very simple scale where we scale just a touch, like 8, what ends up happening to us versus the player? Howdy, Revere. Back to Windows today, indeed, yes. So, is the player moving at all? I feel like the player needs to do the opposite. It needs to move faster. Let's see. Or we need to move slower. Hang on. So this is a 20% reduction. I'll do that. So this should be an obvious. Oh, that is horrendous. What you're struggling with right there, Dimitri. Yeah, so we're slowly overtaking this guy. That's fine. What I want to make sure is can we match that speed? So that means the duck is slower, so we need to go slower. So let's see if I can go slower relative to the duck's speed. That's my next goal. So if I go to player. Now if I take this and I scale us down, because we need to be slowing our camera speed down by 0.9. How does that affect everything? Are we the same speed now, or what? No. Now if I scale it down by a crazy amount, like just an order of magnitude, how does that affect us? Are we faster or slower than a duck? I think we are... No, it's... Yeah, we're still faster than the duck. We're just moving a lot slower. Which is fine, because that's good for one thing. We can slow ourselves down, but we need to slow ourselves relative to the duck. Which is not working. Yeah, set view... New velocity. Let's just... Because this is all just multiplied by and added and all that kind of stuff. I don't really get this, to be honest. Right, so I'm going to try and just get rid of this desired velocity, because I think this is for other things. So current velocity... Ah, okay, hang on. I assume this returns a number, right? Right, we'll see. Can you do this, physics engine? Yes. Very good. It's a GCC error I got. I switched to Clang. Nope. Okay, so that's even slower actually. Interesting. Okay, let's speed you up then. 2. You've never encountered the internal compilation error. Lucky. Okay, so we're just going way faster than the duck now. Okay. And it doesn't matter if I just increase this by, like, if I do this, right? Basically not moving at all. Because we end up just so slow, yet we're basically still. And we're still going faster than the duck. We're still going faster relative to the duck, which is funny. It's the same speed relative to the duck, which is annoying. But yeah, this is a lot of gobbledygook here. I guess I haven't done anything esoteric enough. Yeah, I guess so. Only bugs in my own code and libraries. Yeah, I found code and libraries. That's a bit more common. I used to find these... Have you ever crushed the compiler? I feel like that's like the most basic internal error, where you just crash the compiler somehow. I'm studying fragment shaders, but I feel like I don't understand how those implement though. You've got to understand what fragments are. They're not pixels. They're called fragments for a reason. You can effectively think of them as a pixel with a position, data, and stencil and depth. Then you'll be able to make sense of it a bit more. So it has RGBA, right, obviously. But it has, it also has depth, stencil, and position. You don't have access to some of those things. Like, you don't have access to anything to do with the position. That's to do with the rasterizer. But yeah, they're a bit more chunky than regular pixels. That might help you out understanding what you're doing a bit more. Hence, it's called... despite that, DirectX calls things pixel shader, I think, to avoid confusion. Right, I'm trying to think, like... I actually don't know why they call them pixel shaders. I don't know why I'm claiming that. I can know that. Excuse me. Yawn at the end. Okay, right, let's keep going. So if we scale things... hang on. When I initialize the physics engine, that's what we need to do. This is a initialize physics engine thing, right? If I set things up, like set gravity, set all this kind of stuff, right? So when we're doing this, can we set... like set scale? I don't think that's going to be here, but... So set friction, set restitution. Okay. Right, physics settings. Okay, yeah, so we have... That's fine. Okay, so we have a bunch of internal stuff that I don't really want to touch. Yeah, we just need to slow everything down with dampening, I think. Because right now, when we scale everything down, we're just hugely overscaled. Minimum velocity, restitution, body time, points, determinist. Hi project, how you doing, dude? Good to see you again. Hope you're having a great day, whatever you're up to. So there's nothing in there that's that useful. Set gravity. Yes, we want to turn that off. Okay, there's a lot of gets in here which you don't care about. Okay, so we have like constant stuff. How are you doing, my G? I'm doing great. I was on a bit of a slump earlier, but I've decided to change tack to trying to make everything look nicer by making everything smaller. Everything in our thing is too big. So we're trying to make things a little smaller, make things a little bit make more sense. So what I need to find is dampening. So the first thing I need to fix is the physics engine. It needs to respond to everything being smaller. But I don't know where that would be. Okay, so let's damp. I'm sure it'd be here, so yeah. The models are scaled to 1 to 1. And yes, cleaning upgrade. Yeah, pretty much. Fragment shader is established. The color of pixels by pixel. Yes. Oh, sorry. Yeah, I should have said that. That's actually more important to know if you didn't know. The fragment shader runs per pixel. So you got to think about it like this. If you have a texture and you upload it to the fragment shader isn't running per texture, right? It's not like sticking an image on a triangle or something like that. That would be like what the vertex shader was doing. What you're doing is you're running the fragment shader per pixel and saying, okay, based on this texture at this coordinate with the texture coordinates, for example, what is that pixel's color? Right? That's how it works. And we go, okay, right. Now, there's a bunch of fragments that are going to be thrown away that aren't used. There would be like ones that are, let's just say that you can discard fragments if you don't want to use them. You can also what is it, like make the viewport and scissor different. So if you make the scissor really small, then a bunch of fragments are never going to be used, which is just making like the screen small, right? You know, let's just say that you have a massive like a window like this. A scissor would just be a tiny little rectangle in the middle, and all the fragments would only be in that rectangle. So yeah, it's like that's what the fragment shader is doing. So you need to think about when you're running the fragment shader, even though you're passing in big things like textures, which are a whole image, vertices, which are like a whole mesh, it's only concerned with each current pixel. That's why the fragment shader is expensive, by the way, because it has to do things per pixel. Now, the GPU is massively parallel and does these things extremely fast. But at the end of the day, it still has to color in each pixel with some color. So it is slow. So you have to be careful with that fragment shader, not to make it slow by accident. Everything you're doing, though, using is... Oh, sorry, music is so loud you can't listen. Yeah, thanks for the reactions. Okay, so tell me what you didn't hear, and I'll explain stuff again. So while I go to the physics engine, yeah, some of the music's a bit loud. I do apologize. Let's. I think this goes on and on and on. So let's go to this. So yeah, the fragment shader is per pixel basically, and if you have a texture, it's sampling per pixel of that texture at a particular coordinate and applying it to a fragment. And a fragment is a pixel with positional data encoded into it. You don't have access to that positional data, by the way. It just knows where it needs to be based on what you've told it to. So it samples that. So let's just say it samples a I don't know. So it could sample the texture at 0, 0, and then because your texture coordinates for the next pixel are 0.5, 0.5, it'll go to 0.5, 0.5 on that texture and sample from that pixel and then put that on the next pixel right next to the first pixel, right? So it's doing that sampling technique over each pixel. It's like moving things per pixel around. It's also expensive to do lighting. That's why lighting is expensive, because it has to do it per pixel. And you can end up making things really slow by having like 1,000 lights in the scene, doing like a lot of calculations unnecessarily per pixel for every single thing in the frame, right? Yes, that's why it's called the pixel shader. Yes, in DirectX 100%. We call it the fragment shader. Well, Chronos has decided to call it the fragment shader because you technically... Chronos is working with fragments, which are a pixel with extra metadata. Where am I going? I'm going to my physics engine. So it's not technically... it is really, but it's not technically... Where's the physics? I keep going blind to it. Okay, here it is. But it is for the most part, right? It's just exactly the same. Okay, so we have physics system, initialize a number of bodies, constraints. Okay, so we've got all that stuff in there. What else is it initializing? Nothing interesting. Nothing in here that's interesting at all. How do we make this slower? That's the thing. Job system. It's got to be in here somewhere, because it's got to be in the physics system, right? Like, I want to say... As far as I can tell, we need to make things smaller. Well, the physics system update on a smaller scale. Maybe, okay, maybe it's in the body system. I don't know. Yeah, that confused me for a while, basically. I didn't understand that the fragment shader was, like, sampling things per pixel. Go to there. Oh. Don't I see anything inside here? Yeah, okay, weird. Right, okay, fair enough. So set position and rotation when changed. Oh, that's actually might be good. Set position and rotation when changed. Interesting. So we got a when change, which might be an optimization we can use. Yeah, hopefully Raj, that was after me yelling over the music. Yeah, I don't know why the music's all of a sudden got like really loud. People are saying that they couldn't hear it originally, and now it's like blasting. How long it took you to learn OpenGL? I never did anything that interesting in OpenGL, to be honest. The best thing I did was that I just copied the Hazel game engine in 2D. I did do some 3D things, but it wasn't that interesting. The best thing I did was probably the wind engine stuff, which you can see a screenshot on my GitHub, but it's still not that impressive. So I wouldn't compare yourself to other people either. Not that it's... I know you're trying to just get a barometer to see how well you're doing. But sometimes it's... What I like to say, it takes as long as it takes, right? If a problem that you're working on takes you years, that's how long the problem needed to take. It doesn't matter if it took someone 5 minutes and it took you 5 years. For you, that's all that matters, because you're you. It doesn't matter what anyone else does. And that's just how long the problem needed to take. The problem was going to take 5 years no matter what you wanted to do. Whether you worked on it every day for, 10 hours or you worked on it every day for 1 minute. It was going to take 5 years regardless. You just need to spend that time. If you want it to go faster, you want to learn faster, you've just got to put more time in each day. Then you didn't study OpenGL books. No, I kind of went online. I did a lot of online resources. I think Learn OpenGL is definitely the best. Couldn't have said it better myself. There you go. Thank you, Mabdu. So I can recommend... The only thing I can recommend is because what other people recommend is learnopengl.com. That's probably a good resource to kind of get your teeth into stuff. A bit paranoid now, the music's too loud. No, I think we're good. I think we're good. Yeah, I like that mindset as well. The reason I like that mindset of the problem was going to take the problem is going to take as long as it's going to take kind of thing. It's because it puts you in control. If you want to solve the problem faster, work longer and harder. There's no way around it. you can learn other things to solve the problem. But yeah, if you think like, oh, someone else learned the problem really fast and I'm stuck on this, then you're forever going to be beating yourself up for no reason. Delta time is this. Do I even use that? Hang on. That's what I've been following for the last 20 days. Well, you're on a good resource. It's not perfect. There's a couple of mathematical issues, but apart from that, it's absolutely fine. Yeah, so I think you just... Yeah, collision's best step. You don't want to mess with this at all. I can't see any way to customize this at all. How do I... Yeah, I'm gonna Google this. Hang on. How do you do integrals in code? You kind of don't. You kind of mostly estimate them. So we either derive results and kind of just get the integral that we would find, like, let's just say we decided to do something super basic, like we got the integral of the area of a square, right? Well, obviously we can just go, all right, we don't need to actually do that. We can just go, all right, the area of a square is, 4 or whatever. Or we have to do other techniques like get kind of close, kind of like estimate it. You can do stuff like approach the limits. You almost never want to solve them analytically. You want to either do something like the Monte Carlo approach if you're doing something intense that's really complicated, and kind of like work down the errors. But yeah, you pretty much either derive them or you kind of get them offline, kind of like, oh, that's what it means, that's what it solves to, it's a simpler solution. And to do those things, often we have to simplify the integral down into something that's like kind of close to what we're doing. It's like, so it takes a lot of like manipulation to avoid having to do integrals. So how do you slow down the Jolt physics engine? Avoiding physics processing. Yeah, how do we set the linear dampening? Okay, so I'm going to see... Okay. Jolt physics linear dampening. So it must be this, right? It's like super simple. Set spring? No. Yes, I know. You studied Monte Carlo integration for a while? Yeah. I don't know why you need it. That is to help with ray tracing. That's the basic principle of like how ray tracing slash path tracing works at all. I won't go into it, but basically we're solving an integral for the rendering equation. And if you want to kind of guess, kind of get close to what that pixel should look like, because we have to do these integrals per pixel for the rendering equation, which makes things really expensive. Right, I'm going to say dampening or something. Maybe it's like, oops, that's not how you spell anything at all. Yeah, please take me to something. Linear, please. Where is this? Okay, so great. Oh, interesting. Linear and angle dampening. Angular dampening. So it's really? It's per body, not per. That's really. Why is it like that? Well, I'm assuming there's a good reason. Okay, so. So yeah, you would need that for ray tracing, basically. Nope. There we go. No. Where is this defined? Okay, so set m linear dampening 0.9. I know this is just for movement, but still. Angular dampening. So I kind of want to do this for everything just for a minute. Okay. And I'm just like redoing this over and over again, but okay. Isn't Monte Carlo the pattern that forms from multiple branching projections? I don't think so. No, I don't think it is. No, it's like if we try to okay, that didn't do anything. But I don't think I'm doing this in the player. Hang on. Yeah, okay, so there's a player setting as well. Alright. Player. Oh my goodness. Player setting. This linear dampening. To be honest, I think it might be easier if I just scale these down I might just scale them down in Blender, to be honest, all these things. In school/college, we studied maths, but don't even know how to apply it. But studying graphics programming, math makes sense now. Hell yeah, brother. Where's linear dampening? Linear. Where's the dampening gone? Oh, this is character. Oh no, this is character. Oh, this is really annoying. As far as I'm aware, this character setting might not be the same. Yeah. Oh no. Okay, is there anything in here? Maybe I should move to box 3D. No, so I obviously say that jokingly. There is a marble falling down experiment where there's a 50-50 chance to it fall to the left or the right, so they end up falling to a Monte Carlo curve every single time. Cool. I haven't heard of this. I haven't heard of that falling experiment. A lot of it, what I was learning was like maybe specific to ray tracing. But newer equals must be better, right? Yeah, exactly. We all know this to be true. Where is the dampening for anything other than bodies? Because this is going to be very annoying if I... Why can't I set the linear... I must be able to set the linear dampening for other things. There's no way. It just seems insane that I have to set it per body, because not everything's a body. I mean, I can get the body, I guess, of the character, but I don't know if that actually has effect on its movement. Like, do we have a body in here? Yeah, get body ID. So that does exist, but it's like kind of stupid, it feels like. You know, I just... Yeah, when we construct a character, do we do anything here with anything at all? Oh. So it's just character settings in on a body creation. Why can't we set this globally? Okay, so I'm just going to try just like breaking this a little bit. I can do this because I'm compiling this source code myself. Right, obviously don't do this. This is like bad. But I want to see if this even works, right? If it's even like what I want to try and pursue. Search Galton board. Sure. Oh, a normal distribution. Is that what you're talking about? Hopefully don't make a really loud noise, please. Yeah, normal distribution. Is that what you took? Yeah. I didn't realize you were talking about a normal distribution. Oh, no, we're still moving way faster than the player. In fact, I didn't get to see. I don't think that's Monte Carlo though. Maybe it is. I don't know. Okay, so that didn't do anything at all. So that's not what we want. It's almost like we need the opposite. It's like faster. But that doesn't make any sense to do it like that at all. Yeah, that doesn't do anything at all. Okay, that's good to know. That's not what we wanted. What am I trying to do here? I'm trying to do something with the physics engine. And I just... Yeah, I'm trying to get Control Z so we don't actually mess with this. It must be. If we scaled everything down, we must be able to scale down. I wonder if the engine has any concept of scale. I'm just going to minimize that for a minute. Like, scale. Not CD renderer. So if you take the physics... is there anything to do with scale here? Previous... I'm going to do a pair project search, I think. So if I go in here, select that. Just look for every instance of scale within current project. Because I just need to know. No, it's just done it for... Why is it done it for that? Have I clicked the wrong thing? Okay, void. No. Not SDL. Not video. Not Vulkan. Yeah, I don't... What is happening? Scale definitely exists. Get scale is a thing. Monte Carlo algorithms are a class of algorithms that approximate a more complex system with randomness. Yeah. Yeah. So, like for an integral, for example, if we're trying to work out a really complicated, I don't know, sample for a point, and we need to integrate some massive integrand over infinite directions over a hemisphere, then it's very easy just to pick one of those hemispheres, one of those points on the hemisphere, and kind of do a single integrand over that, a single 1 point, and then we can get like an idea of what that might be. Increase the number of samples per point, and then we get closer to actually what the color should be. Oh no. Yeah, again, I haven't formally trained in mathematics, so a lot of my mathematics is very... it's what I call game dev maths. or a graph, or for a graph problem, you might just pick the next node randomly and repeat it until you get an accurate answer. Yeah, that makes sense. That makes sense to me. But maybe, I don't know, maybe the way that the ball falls down into a normal distribution is kind of demonstrate as like randomly sampling over in one dimension. I don't know. And you get like a normal distribution if you have a 50-50 split or something. I can kind of see it, but I don't know if that's rigorous. I don't know. Like correct, I say rigorous. It's nothing we're saying is rigorous. No, we need to find this thing. I need to dig this up. I don't know. What am I trying to do here? If I scale down everything in the thing, if I get a body interface, no, I don't think body interface has anything to do with anything when it comes to this. It's just like about creating and doing body stuff. And scale does not appear in here, does it? I've done this already, haven't I? Is it the number of steps you have to do is less? Yeah, because I need this to affect everything in the game. That's why I'm kind of taking my time with this. I can't just say like, oh yeah, the player moves slower. Oh, you hear Daft Punk? Sorry to disappoint, it's good old Fury. Great track. I've got the mixed version, which has all the different states of the fighting. Yeah. No, it's not delta time. I don't think I need to fix. I mean, that would slow everything down. That's what I want then. Yeah, let's see. Let's see. But I don't... I need to also scale the objects as well. But no, this doesn't work. You have to basically set the collision engine to be 0, like a very, like if it takes longer than 1/60th of a second, you need to do multiple collision steps in order to keep the simulation stable. Do one collision step per 1/60th of a second. This is very... If you get this wrong, it kind of completely breaks. It's not... Unstable is a understatement, honestly. It just does not work. I just don't understand how you make this slower at all. Like... Okay, maybe I'm just being stupid here. We just need to scale the objects, and that's it. Yeah, so what I'm going to try is, instead of... Yeah, okay, so what I'm going to do is I'm going to go into player and just see if this works. This is just a Hail Mary, right? So we have shape reference, degrees, max slope. I don't know what any of these mean. Model shape. So if I just take this, scale it down by no, that would be double scale. That's for the that's not what I need. What I need is whatever the shape is of the actual geometry, I think. So this shape ref before player intit. So where's player intit run? I'm trying to slow the physics engine down, but I think I need to scale the objects that are in the physics simulation down to do that, because I need to scale everything down by a certain level. As far as I can tell, when I do get shape, what do I get here out of this? What is happening? Oh, no, this is correct. Okay, so okay, that I want to. Okay, build scene. Okay, so what I'm going to do here is get rid of these while I'm here. And what I'm going to do is reduce the scale, literally just this, which is player settings, right? Which is the shape itself. If I times that by the scale .9, and it seems silly to do this, maybe that. Yeah, that's I'm just trying to figure out like how the physics engine would want to do what I'm trying to do in a way that makes sense. So I think it maybe make the objects smaller or bigger. It just feels even slower now. I don't understand. I don't know. It just feels like. Yeah, the music definitely had rad music. No, you see we're moving faster than the player. The player is moving, but it's moving too slow. Wait, what? If the object's moving too slow, that's scaled. No, that's fine. We need to be moving at the same speed. Yeah, no, the physics engine is moving us. We need to be moving slower relative to the position of this. Yeah, okay, that makes sense. Sorry. I don't know. I thought that might be it, because if I make this bigger, I put this by 10, for example. Actually, that might not do anything. Use less force. How do I? Yeah, that's the thing. I'm not trying to. See what I mean? Like, I could make the object bigger, but that doesn't do anything. All right, it's 5 o'clock, so I'm going to share my Discord server. Actually, remember to do it this time at the right time. Here you go. And yeah, that's my Discord server if you want to join. Thank you all for joining us. It is time to call it. I hope you've had a great stream. I know it's tough for me. I was like slugging it out around 2 o'clock. I was like, ugh, I don't know if I'm going to continue, but I made it. Yeah, thank you for anyone who's thank you for everyone staying subscribed, you know, liking and comments on the live stream and stuff like that. Very much appreciate you all. Thanks for all the new subs. If any came my way, I very much appreciate you guys. Yeah, and I hope you enjoyed yourselves while you were here. All right, I will see you all shortly. All right, bye guys. Bye.